Hello there, and welcome to the Cosmographer. A fire aboard the International Space Station once went out, and then kept burning for another 40 seconds with nothing at all to see. No flame, no glow, nothing any camera aboard could detect. That is number 16 on this list. Number 18 is a 7mm crater in a window, made by an object a few thousandths of a millimeter across. Number 9 is lightning that leaves the top of a thunderstorm traveling upward and does not stop until 90 kilometers, a phenomenon pilots reported for 50 years and were quietly disbelieved about. Number 2 is the inside of a space station found dark, silent, and coated in frost, 4 months after it stopped answering. Over the next 4 hours, we count down 20 things astronauts have looked at and could not account for, ordered by how completely each one breaks the assumption that a trained observer in orbit can trust their own eyes. Get comfortable and settle in. If falling asleep to the strange edges of spaceflight is your idea of a good night, a quiet like and subscribe genuinely helps this channel reach more people who feel the same way. Because the thing at the top of this list is not outside the spacecraft at all, and there is no way to look away from it. Let's begin at number 20. Number 20. Water that climbs instead of falls. This is a list of 20 things that human beings have looked at from inside a spacecraft and, in the moment of looking, could not account for. Some of them turned out to have ordinary explanations that took years to find. A few of them have no confirmed explanation even now. And the last 2 are not outside the spacecraft at all. What connects them is not strangeness for its own sake. It is a single assumption coming apart, slowly, over the course of the next 4 hours. The assumption is that an astronaut can trust their own eyes. These are the most carefully screened observers any society has ever produced. They are selected for calm, trained for years, and tested against every failure anyone could imagine in advance. And the environment they work in keeps handing them things their training did not cover. We begin at the gentlest end of that, with an experiment designed by 2 teenagers. On the 16th of April 2013, Canadian Space Agency astronaut Chris Hadfield ran a live demonstration aboard the International Space Station. The experiment was not his. It had been designed by 2 10th-grade students, Kendra Lemke and Meredith Faulkner of Lockview High School in Fall River, Nova Scotia. They had won a national science contest with a proposal titled "Ring It Out," and the question they wanted answered was about as simple as a question can be. What happens when you wring out a soaked cloth in weightlessness? Their hypothesis was that the water would not drip. That turned out to be correct. What actually happened was considerably stranger than anything they had predicted. Hadfield soaked a standard station washcloth and began to squeeze it. The water did not leave the cloth and fall, because there is no down for it to fall in. But it also did not form drops, and it did not spray outward, and it did not do any of the other things a reasonable person might guess. Instead, it migrated outward onto his hands, and formed a continuous, connected sleeve of liquid that wrapped the cloth and his fingers together into a single wet cylinder. His description on the live feed was accurate and slightly bewildered. "It is becoming a tube of water," he said. And then, a moment later, the water is all over my hands. In fact, it wrings out of the cloth into my hands, and if I let go of the cloth carefully, the water sort of has its stick to my hand. The harder he squeezed, the larger the water jacket grew. It did not go anywhere at all. It simply enveloped the source of the pressure and stayed there, a glove of liquid holding itself together around a man's hand, 390 kilometers above Nova Scotia. The physics behind this is worth stating precisely, because the usual shorthand for it is wrong in a way that obscures the whole point. Astronauts on the station are not in zero gravity. At 400 kilometers of altitude, the Earth's gravitational pull is still roughly 90% as strong as it is at the surface. If you could somehow stand on a tower that tall, you would weigh very nearly what you weigh now. What the crew is actually in is freefall. The station is falling around the planet, and everything inside it is falling at exactly the same rate, which means nothing inside presses against anything else. Gravity has not gone away. It has simply stopped producing any relative force between the objects in the room. And that is what changes everything, because a great many familiar phenomena turn out to be consequences of relative force rather than of the substances involved. Remove it, and hydrostatic pressure gradients vanish. Buoyancy vanishes. Sedimentation vanishes, so nothing settles out of anything. Natural convection vanishes, so warm fluid no longer rises, and cool fluid no longer sinks to replace it. Every one of those effects is something people think of as a basic property of liquids, and every one of them is really a property of liquids in a gravity field. What is left standing, when all of that switches off, is surface tension. On Earth, surface tension is a minor character. It is strong enough to hold a droplet on a leaf, or let an insect stand on a pond, and at any scale larger than that, it loses to gravity immediately. In orbit, it does not lose to anything, because there is nothing left for it to lose to. Engineers describe this with a quantity called the bond number, which is simply the ratio of gravitational force to surface tension force. In orbit, that ratio falls essentially to zero. The practical consequence is a kind of inversion of scale. A liter of water in orbit behaves the way a microscopic droplet behaves on a countertop on Earth. Liquid climbs into corners. It coats walls. It bridges gaps between objects. It refuses to pool, and it refuses to be poured. Free water released into the cabin relaxes into a sphere, because a sphere encloses the most volume for the least surface area, and surface tension is now the only sculptor working in the room. Crews have made use of these spheres. In January 2015, the station received a high-end cinema camera capable of resolutions up to 6K and frame rates up to 300 frames per second from the same camera family used to shoot large feature films. Astronauts injected effervescent tablets and colored dye into floating water spheres and filmed what happened, and the footage was released in October of that year. The images are beautiful, and they were not made for that reason. The scientific justification is entirely practical. Understanding how liquid behaves when gravity is not organizing it underpins the design of spacecraft fuel tanks, thermal loops, and water systems. A rocket engine that cannot reliably draw propellant from a tank is not an engine. Getting that right requires knowing exactly how a fluid will arrange itself inside a container when nothing is pulling it toward the bottom. The formal work on this has been running for a long time. The capillary flow experiment began operating aboard the station in August 2004 and ran through December 2007, with at least 16 separate operations conducted by 5 different astronauts. The hardware was deliberately unglamorous, 6 units, each weighing only 1 or 2 kilograms. What it was probing is not unglamorous at all. One of the phenomena it examined, the moving contact line boundary condition, describes how the leading edge of a spreading liquid actually behaves at the point where liquid, solid, and gas all meet. That remains an unsolved problem in fluid mechanics. It was flown into orbit specifically because weightlessness slows the process down enough to watch it happen. There is one more consequence of all this, and it is the one that affected daily life aboard more than any other. A normal cup does not work in space. On Earth, a cup works because gravity keeps the liquid pooled at the bottom and delivers it to your mouth when you tilt the rim. In orbit, the liquid neither pools nor pours. It clings to the interior walls as a blob and stays exactly where it is, no matter what angle you hold the cup at. That is why crews drank from sealed bags through straws for decades. It worked, and it was also a small daily loss, because a sealed bag removes aroma almost entirely. Since most of what people call taste is actually smell, coffee drunk through a straw from a foil pouch is barely coffee at all. The solution came from an astronaut who decided to work with the physics rather than against it. Don Pettit designed a cup with an interior corner running from the base to the rim, so that capillary action wicks the drink up the channel and holds it at the lip, where a person can simply sip it. 2 patents cover the idea, filed in November 2009 and November 2014. On the 3rd of May 2015, ESA astronaut Samantha Cristoforetti used one of them to drink the first espresso ever made in orbit. She was wearing a Star Trek uniform at the time, which is the sort of detail that gets remembered instead of the engineering. The engineering is the point, though. Every intuition a human body carries about liquid, that it falls, that it pools, that it can be poured, that a cup is a solved problem, was learned in a gravity field over the course of an entire evolutionary history. The moment that field stops producing relative force, those intuitions do not merely become useless. They become actively wrong in ways that can flood a wall panel or drown an instrument or leave a crew unable to drink from an open container. Water climbing a hand is the mildest version of this and the most cheerful. It is also about as far as this list gets from anything that could hurt anybody. But water that will not leave a cloth is at least still where you left it. The next entry on this list concerns things that left a spacecraft and did not come back. Number 19. The things that got away. On the 3rd of June 1965, Edward White II became the first American to walk in space. He floated on a tether outside Gemini 4 for about 23 minutes, while James McDivitt flew the spacecraft and took the photographs, and those photographs became some of the most reproduced images of the 20th century. White is in a white suit against absolute black, gold visor down, a thin umbilical trailing back toward the hatch. With that hatch open, something else left the cabin. A spare thermal glove drifted out and became one of the earliest pieces of human-made orbital debris. A single glove, alone, traveling at roughly 8 kilometers per second, which works out to about 28,000 kilometers an hour. It is worth pausing on the honest limits of what is known here, because this story is usually told with a detail that cannot be supported. The frequently repeated claim is that the glove orbited the Earth for about a month before burning up. That figure cannot be verified. Neither NASA nor the Smithsonian, which holds White's flown Gemini 4 gloves in its collection, states any duration at all. Given how low an orbit Gemini 4 flew, decay within a few weeks is entirely reasonable physically. But the specific number is an estimate that has hardened into a fact through repetition, and it belongs in this account as the estimate it is. The image survives regardless. For some period of days or weeks in the summer of 1965, there was a glove in orbit around the Earth, moving faster than any bullet ever fired, gradually losing altitude to the thin traces of atmosphere at that height, until it came apart in a streak nobody saw. 13 months later, Michael Collins lost a camera. Gemini 10 launched on the 18th of July, 1966, with John Young and Collins aboard. During his spacewalk, which included the first rendezvous by a human being with a separate uncrewed spacecraft, an Agena target vehicle, Collins was concentrating on keeping his umbilical clear of both vehicles at once. That is a genuinely difficult problem. A tether that snags on a protruding structure at orbital closing speeds is not a nuisance, it is a serious hazard. While he was managing it, his 70mm Hasselblad worked loose from his suit and drifted out of reach. He lost every photograph he had taken outside. More than a decade later, Hasselblad made an advertisement out of it, titled "The Launch of the First Swedish Satellite," which is a considerably better joke than the company had any right to. The camera is not still in orbit, despite how durable that claim has proven. It almost certainly re-entered within weeks, the same way the glove did. The best documented loss in the history of spaceflight happened on the 18th of November, 2008. During the first spacewalk of STS-126, Heidemarie Stefanischen Piper was working to clean and lubricate a jammed solar array rotary joint, a large bearing that lets the station's solar wings track the sun. It is dirty, awkward work performed in a pressurized suit with gloves that resist every movement of the hand. While she was working, a grease gun leaked inside her crew lock bag. And while she was cleaning up that mess, the bag, which had not been properly secured, drifted free. The bag weighed about 30 pounds, or 14 kilograms, and was roughly the size of a small backpack. Inside it were 2 grease guns, a scraper tool, wipes, and trash bags. The replacement value of the contents was about $100,000. Her account of the moment, given in a televised interview the following day, is the most human thing in this entire entry, and it is worth quoting in full. "There was that split-second thinking that maybe I can go jump for it and grab it," she said. "Then I realized that it would just make everything worse, and then we'd have 2 floating objects, one of which would be me. So the best thing to do was just to let it go." That is a very good description of judgment working correctly under pressure. The instinct is to lunge. The training is to notice the instinct, follow it one step further to its consequence, and decline. What happened next is what makes this entry more than an anecdote. The bag was bright enough to be seen from the ground. Amateur satellite observers picked it up with binoculars, filmed it, and tracked it night after night. It appeared on public satellite tracking websites under the plainest label imaginable, ISS Tool Bag. The United States Air Force Joint Space Operations Center at Vandenberg was tracking it at the same time, for entirely different reasons. It stayed up for more than 8.5 months. It re-entered on the 3rd of August, 2009, over the Pacific just west of Mexico. For most of a year, anyone with a pair of binoculars and a decent almanac could go outside and watch a lost bag of tools cross the sky. There is a 4th case that belongs here, with a caution attached. Sunita Williams launched aboard Discovery on the 9th of December 2006, joining Expedition 14, and during a spacewalk that month, a camera drifted away from her untethered. The exchange with Houston that followed, a hopeful "I hope it's tethered," answered by a rather strained acknowledgement, is quoted constantly. It should be said honestly that the contemporaneous documentation of this incident is thinner than for the tool bag. The exact date of the spacewalk is not consistently reported, and viral clips of astronauts losing equipment are sometimes misattributed to it. The loss is reported. The details around it are softer than they are usually presented. Individually, these are charming stories. A glove, a camera, a bag of tools. Collectively, they are the opening chapter of a problem that has since grown to a size that is difficult to hold in the head. According to the European Space Agency's Space Environment Report for 2025, about 40,000 objects are actively tracked by space surveillance networks. Only about 11,000 of those are functioning payloads. Everything else, roughly 3/4 of everything being watched, is junk. And tracking has limits. Statistical modeling, which fills in what the radars cannot see, puts the true population at over 50,000 objects larger than 10 centimeters, over 1.2 million larger than 1 centimeter, and roughly 130 million larger than a millimeter. The number that matters in that list is the middle one. 1 centimeter is the threshold at which a fragment becomes capable of catastrophically destroying a spacecraft. Not damaging it, destroying it. There are over 1 million such objects up there, and only a small fraction of them can be seen well enough to be avoided. The reason a 1 centimeter object can destroy a spacecraft is velocity. Objects in low Earth orbit travel at roughly 7.8 kilometers per second, which is about 8 times the muzzle velocity of a rifle bullet. Because orbits cross at angles rather than meeting head-on, typical impact speeds average around 10 kilometers per second, and a genuine head-on encounter can reach about 54,000 kilometers an hour. At those speeds, the material properties of the object barely matter. A fragment of aluminium and a fragment of ice deliver comparable energy. What matters is mass and closing speed dominates completely. The runaway version of this problem is named for Donald Kessler, the NASA scientist who described it with Burton Coeur Palais in a paper published in 1978. The idea is straightforward and unpleasant. Each collision produces fragments. Each fragment is capable of causing further collisions. Past a certain density, the population sustains itself, and particular orbital bands become unusable not for years but for generations. It is no longer hypothetical. On the 10th of February 2009, the defunct Russian satellite Cosmos 2251 struck the operational communications satellite Iridium 33. The collision produced 2 large clouds of trackable fragments that are still being catalogued more than 15 years later. Neither spacecraft was maneuvering. Nobody had judged the risk high enough to act on, and the 2 vehicles simply arrived at the same point in space at the same moment, closing at something on the order of 11 kilometers per second. And the European Space Agency's 2025 report contains a finding that deserves to be stated plainly, because it is the whole problem in one sentence. Even if every launch on Earth stopped tomorrow, the debris population would continue to grow. Fragmentation events add new objects faster than atmospheric drag removes the old ones. The agency's conclusion is that active removal of debris is now required rather than optional. All of which began, in a modest way, with a spare glove drifting out of an open hatch above the Pacific in 1965, while a man on a tether had his photograph taken. And one of those fragments, far too small for anyone to see coming, eventually found a window. Number 18. The chip in the window. In May 2016, British astronaut Tim Peake published a photograph he had taken from inside the International Space Station's cupola. It is not a dramatic image. It shows a small, almost perfectly circular chip gouged out of one of the windows, with fine fracture lines radiating outward from it like a splash that has been frozen in place. The European Space Agency released it under a title with no embellishment at all: Impact Chip. Peake's own comment was equally plain. "Yes," he wrote, "this is the chip in one of our cupola windows. Glad it is quadruple glazed." The chip is 7 millimeters across. That is roughly the width of the eraser on the end of a pencil. What made it is the part worth sitting with. The European Space Agency's assessment is that the impactor was possibly a paint flake or a small fragment of metal, no bigger than a few thousandths of a millimeter across. An object far too small to see with the naked eye, for practical purposes, a speck of dust, excavated a 7-millimeter crater in fused silica glass. The arithmetic that permits this is unforgiving, and it comes down entirely to velocity. The station orbits at roughly 7.7 kilometers per second. Typical debris impact velocities average around 10 kilometers per second and can approach 15 in a head-on encounter. Kinetic energy scales with the square of velocity, which means that when the speeds get high enough, mass very nearly stops mattering. Double the mass and you double the energy. Double the speed and you quadruple it. A historical comparison makes the point cleanly. During STS-7 in 1983, a paint chip 0.2 of a millimeter across struck a window of the Space Shuttle Challenger and left a pit 0.4 of a millimeter deep. A flake of paint that had come off some other spacecraft years earlier was now traveling fast enough to dig into a window and leave a mark twice its own diameter. The cupola itself deserves description, because the window that took Peake's hit is not a window in any ordinary sense of the word. Built by Thales Alenia Space for the European Space Agency and installed on Node 3, Tranquility, the cupola is a small domed observation module with 7 windows. 6 of them are trapezoidal side panes arranged around the circumference. The 7th is a circular top window, 80 centimeters in diameter, the largest window ever flown in space. It is the module from which nearly every famous photograph of Earth taken in the last 15 years has been made, and it is where crews go to look at the planet when they have half an hour to themselves. Each of those windows is a stack of 4 separate panes, and each pane has a distinct job. Innermost is a scratch pane. Its only purpose is to protect the structural glass from accidental knocks from inside. A camera lens, a boot, a piece of equipment floating loose. It carries a heater to keep condensation off. It is expected to get damaged, and it is designed to be replaceable. Behind that sit 2 fused silica pressure panes. These are the panes actually holding the cabin's atmosphere in against vacuum, and they are substantial. Each one is 36.8 millimeters thick on the circular window and 25.4 millimeters thick on the trapezoidal ones. 2 of them in series, so that either can fail without opening the module to space. Outermost is a debris pane. It is not structural. It holds nothing in and supports nothing. Its entire reason for existing is to absorb exactly the kind of strike that Tim Peake photographed. There is something worth noticing in that arrangement. 2 of the 4 panes in every cupola window exist purely to be damaged. They are not backups in the sense of spare parts held in reserve. They are consumable surfaces, budgeted from the beginning to accumulate scars, positioned so that anything arriving from outside or inside meets a layer whose loss costs nothing. The design does not attempt to prevent impacts, because preventing them is not possible. It arranges for them to land somewhere harmless. On top of all that, every window has an external shutter that the crew opens and closes from inside with a turn of the wrist. The shutters are kept closed whenever the cupola is not in use, partly to shield the glass, partly to manage the thermal load of a window facing alternately into sunlight and into the cold of space every 45 minutes. So the famous 7mm chip was in a sacrificial outer layer of a 4-pane stack, sitting behind a shutter that was open at the time, in front of 2 pressure panes, each thicker than a stack of coins. It was never a danger to anybody aboard. That is precisely the point worth making about it. The system was designed on the explicit assumption that this would happen. It happened. The system worked. The scratch and debris panes are replaceable in orbit, and crews have replaced them. A cupola window pane was changed out in 2017. The wider record of impacts on the station is more substantial than most people realize, and it is mostly a record of things holding. The station has performed 41 collision avoidance maneuvers since 1999. These are cases where an object was tracked, its path was projected forward, and the projection came close enough that the station was simply moved out of the way. The frequency has varied considerably. 1 maneuver each in several individual years, 2 in others, with peaks of 5 in 2014 and 4 in 2015. The most recent confirmed in NASA's published records took place on the 30th of April 2025, when the thrusters of a docked Progress cargo vehicle fired for 3 minutes and 33 seconds to raise the station away from a fragment of a spent Chinese upper stage. When a threat is detected too late to dodge, the procedure is different and considerably starker. The crew closes the hatches and shelters inside their return spacecraft until the object has passed. If the station is holed while they are in there, they undock and come home. Not everything gets avoided. On the 12th of May 2021, a routine camera inspection found a hole punched clean through Canadarm2, the station's main robotic arm, in service since 2001. The hole was approximately 5 millimeters across and went through both a boom segment and its thermal blanket. Nobody had detected the strike as it happened. It was found by looking. The Canadian Space Agency announced it on the 28th of May and concluded that the arm's performance was unaffected, which it has been ever since. Larger events exist. As of a NASA survey published in 2019, the largest observed impact damage anywhere on the station is a strike that punched through one of the port-side radiator panels. In July 2014, managers evaluated apparent debris damage to a photovoltaic radiator, with data suggesting a puncture on the order of 12 inches long in the cover sheet. No ammonia leak followed, and the system kept working. And in 2013, Chris Hadfield, the same astronaut with the water-jacketed hands, photographed what he described as a bullet hole through one of the station's solar arrays and attributed it to a micrometeoroid. The arrays accumulate perforations continuously and have done for their entire operational lives. Because they are thin films spread across an enormous surface area, each hole costs a negligible amount of power, and there is nothing to be done about them anyway. NASA's Hypervelocity Impact Group at Johnson Space Center maintains a public archive of these events. It runs to hundreds of documented craters and perforations, accumulated over more than 2 decades of continuous habitation. Looking through it is a strange experience, because it is a catalogue of near misses that were never near anything in particular. Each entry is a small pit or hole in a handrail, a radiator, a truss segment, a window pane, photographed at close range against a scale bar, with no information about what made it or when. The station has been struck constantly for 25 years by objects nobody saw arrive, and the record of it consists almost entirely of damage found afterwards during routine inspection. There is a quiet asymmetry in all of this that is easy to miss. The station is struck constantly and survives because it was built by people who assumed it would be struck constantly. The objects doing the striking were, almost without exception, put there by the same species, on purpose, for good reasons, without anyone intending this outcome at all. All of which is to say that the most photographed window in orbit carries a permanent scar left by something smaller than a grain of pollen. Every crew that has floated up into that dome since 2016 to look at the Earth going by underneath them has looked at the planet through it. That window let light in. It also let in something else that every astronaut who has ever come back through an airlock has noticed immediately, and that nobody has ever been able to photograph at all. Number 17. The smell that comes back inside. There is no smell in vacuum. There are no molecules to carry one, and in any case an astronaut's nose is sealed inside a helmet for the entire duration of a spacewalk, breathing bottled oxygen from a supply that has been filtered and scrubbed and monitored. On the face of it, this entry should not exist. And yet almost every astronaut who has ever performed a spacewalk describes the same thing, in language that is remarkably consistent across 4 decades, several space agencies, and 2 different orbital stations. It is one of the most reliably reported sensory experiences in the history of human spaceflight, and there is no photograph of it, no recording of it, and no instrument aboard any spacecraft that has ever measured it directly. What they are describing is what happens afterward. The airlock repressurizes. The helmets come off. And the suits, the gloves, the tools, and the walls of the airlock itself, every surface that was exposed to vacuum a few minutes earlier, give off something sharp and metallic. It clings, and it is reported to be noticeably stronger on fabric than on metal or plastic. The account that defined the genre came from Don Pettit, who flew Expedition 6 in 2002 and 2003. He was the crew member operating the airlock, which meant his job was to be the one welcoming his colleagues back inside. He wrote about it afterward, and the passage is worth giving at length because of how carefully he refuses to overstate it. Each time, when I repressed the airlock, opened the hatch and welcomed two tired workers inside, a peculiar odor tickled my olfactory senses, he wrote. It is hard to describe this smell. It is definitely not the olfactory equivalent of describing the palate sensations of some new food that tastes like chicken. The best description I can come up with is metallic, a rather pleasant, sweet metallic sensation. It reminded me of my college summers where I labored for many hours with an arc welding torch repairing heavy equipment for a small logging outfit. It reminded me of pleasant, sweet-smelling welding fumes. That is the smell of space. Thomas Jones, who flew 4 shuttle missions and performed 3 spacewalks on STS-98, gave the most analytical version of the same experience. Whenever I got out of my spacesuit in the airlock after an EVA, I smelled a trace of this peculiar, almost acrid odor, he wrote. Astronauts call it the smell of space. I could still detect it as I was stowing my gear or tools in the airlock. To me, the odor was like ozone, hot electrical insulation, or gunpowder. And then he went further than anyone else had and proposed a mechanism. I think the odor is probably ozone-related, he wrote. Outside, atomic oxygen, single atoms, stick to the fabric's exterior surface, and perhaps to airlock walls and tools. This atomic oxygen is created from atmospheric oxygen when struck by solar ultraviolet radiation. When you repressurize, the single atoms of oxygen combine with oxygen in the cabin atmosphere to make ozone. That's what I think I was smelling. That explanation remains the strongest candidate, and it has the considerable virtue of accounting for the details that any competing theory has to explain. In low Earth orbit, the atmosphere has not ended. It has merely thinned to the point where the remaining oxygen behaves differently. Solar ultraviolet light, unfiltered at that altitude, splits oxygen molecules into single atoms. Those atoms are chemically aggressive. A lone oxygen atom badly wants to be part of something, and they adhere readily to whatever surfaces pass through them. A spacesuit moving through that environment for 6 or 7 hours accumulates a coating of them. Then the airlock repressurizes, and the cabin atmosphere arrives. The single atoms find oxygen molecules to bond with and form ozone, along with related species, and ozone produces exactly the sharp, metallic, electrical smell that people already associate with arcing equipment and with the air after a thunderstorm. Nobody has to learn what ozone smells like to recognize it. The explanation also handles the 2 details that make this phenomenon specific rather than general. It explains why the smell is strongest on porous fabric, because fabric has vastly more surface area per unit volume than smooth metal and therefore collects more atomic oxygen. And it explains why the smell appears at the moment of repressurization rather than at any other time, because that is the moment the second ingredient arrives. The descriptions from other astronauts cluster tightly around the same small set of comparisons, which is itself a kind of evidence. Alexander Gerst, flying for the European Space Agency, gave the most specific and by some distance the most memorable. "Space," he said, "smells like a mixture between walnuts and the brake pads of my motorbike." That is not a poetic description. It is a man reaching for the 2 things in his own life that came closest, and finding that neither one quite did it alone. Chris Hadfield has said repeatedly that the airlock smells like ozone or gunpowder, and has publicly described space as smelling of gunpowder and burnt steak. Peggy Whitson, who has logged more than 690 days in space across her career and performed 10 spacewalks, is consistently reported as describing a burnt metal tang, though it should be said that a clean, directly attributable quotation from her is difficult to locate, and the descriptor circulates mostly in paraphrase. Across the whole body of testimony, the recurring words are these: seared steak, burnt steak, hot metal, welding fumes, ozone, hot electrical insulation, spent gunpowder, burnt cake, walnuts, brake pads. Every one of them describes combustion or hot metal. Not one of them describes anything sweet, floral, organic, or cold. There is a second explanation that circulates very widely and that deserves careful handling, because it is half right in a way that makes it misleading. Polycyclic aromatic hydrocarbons are carbon-rich molecules with a structure something like chicken wire, flat sheets of linked rings. They are genuinely ubiquitous across the galaxy, produced in quantity by dying stars, and they are chemically similar to compounds found in coal and in barbecue smoke. Luis Alamandola, who founded and directed the astrochemistry laboratory at NASA Ames, documented just how widespread they are. And they are indeed the family of molecules responsible for the smell of burnt or charred food. All of that is true, and none of it is an explanation for what is happening in that airlock. Interstellar polycyclic aromatic hydrocarbons are not depositing themselves on a spacesuit in low Earth orbit in any quantity a human nose could detect. They explain, quite well, why the universe at large would smell burnt if a person could somehow smell it. They are a much weaker explanation for what is clinging to a glove that has just come in from a spacewalk 400 kilometers above Texas. There is also a quiet piece of evidence in the consistency itself. These astronauts did not compare notes beforehand. They flew decades apart, trained in different countries, and in several cases wrote their descriptions before they had read anyone else's. A shared expectation can produce a shared report. People are suggestible, and the phrase, "the smell of space," had entered the vocabulary by the 1990s. But suggestion tends to produce vague agreement rather than convergent specificity, and what these accounts converge on is unusually specific. Welding, hot metal, ozone. The same narrow chemical neighborhood described independently by people who had no particular reason to reach for it. The third contributor is the least glamorous and probably the most underrated. Thruster residues, volatiles outgassing from suit and station materials, and surfaces that have been vacuum-baked for hours and are now returning to pressure all release something. None of it smells like much on its own. Together, in a small sealed volume with two tired people and a suit that has been outside all day, it adds up. NASA took the phenomenon seriously enough to commission a reconstruction of it. In 2008, the agency approached Steve Pearce, a chemist and the founder of a British fragrance house, and asked him to build the smell in a laboratory. The purpose was training. The reasoning was that if new astronauts encountered the scent for the first time in orbit, it would be one more unfamiliar thing in an environment already made entirely of unfamiliar things, and that removing surprises, wherever they can be removed cheaply, is worth doing. Pearce worked from astronaut testimony, with burnt ozone as the common denominator, and spent roughly 4 years on it. In 2020, the formulation reached the public through a crowdfunding campaign that raised over $380,000 against an original goal of $1,969, the target being a deliberate nod to the year of the first moon landing. Two things about that product need correcting, because they have escaped into general circulation. The widely repeated description of space smelling of seared steak, raspberries and rum is a mashup of two entirely unrelated findings. The raspberries and rum come from a separate discovery in 2009, when astronomers using a 30-meter radio telescope in Spain detected ethyl formate, an ester that contributes to raspberry flavor and carries a faint rum-like scent, in a giant molecular cloud near the center of the galaxy, about 26,000 light-years away. That is a molecule in a distant gas cloud. It has nothing whatsoever to do with what clings to a spacesuit. The second is the descriptor burnt almond cookies, which appears constantly in coverage and cannot be attributed to any named astronaut on the record. It appears to have originated in marketing copy. It should not be put in anyone's mouth. What remains once the merchandise is set aside is this. The only sense a pressure suit cannot fully seal off is smell, because the moment the helmet comes off, whatever came in with the suit is in the room. And so the one direct, unmediated physical impression that a human being brings back from outside a spacecraft, the single sensory fact that is not delivered through glass or a camera or a display, is a smell that reminds almost every one of them of welding. Welding fumes are a reasonable comparison as it happens, because the next entry on this list is about fire behaving in a way that no combustion scientist expected, and that nobody could have discovered without a space station. Number 16. The flame that went out and kept burning. Almost nobody knows what a flame actually looks like. What people picture when they picture fire, the pointed teardrop, the tapering tongue of light, the shape drawn on every warning sign and carved into every jack-o'-lantern, is not the shape of combustion. It is the shape of gravity acting on combustion. Here is why. When fuel burns, the products of that reaction are hot, and hot gas is less dense than the air around it. Buoyancy lifts it. As it rises, it leaves a low-pressure gap beneath, and fresh, cool air is pulled in from below to fill that gap. That inflow feeds the reaction with new oxygen, and simultaneously stretches the whole structure upward into a point. The candle flame is a chimney. It is drawing its own air. Remove gravity, and there is no buoyancy. With no buoyancy, there is no rising column, and with no rising column, there is no draft pulling fresh air in from underneath. Natural convection simply stops. What is left is diffusion, which is slow. Oxygen can reach the reaction zone only by wandering there molecule by molecule, and fuel vapor can leave the burning surface only the same way. The flame settles wherever fuel and oxygen happen to meet in the right proportion, and around a spherical droplet of fuel, that surface is a sphere. Flames in orbit are balls. They are dim, often blue, nearly free of soot, and they burn cooler and slower than anything on Earth. They can also survive at oxygen concentrations that would extinguish a terrestrial flame outright, because they are not fighting a draft that is trying to blow them out. That spherical symmetry is also why combustion scientists wanted them so badly. A teardrop flame on Earth is a three-dimensional mess of turbulence and shear. A sphere reduces the mathematics of combustion to a single dimension, distance from the center. It is the closest thing to a clean laboratory that fire has ever offered. The experiment that found something nobody was looking for was called FLEX, the Flame Extinguishment Experiment, and its original purpose was entirely practical. It ran inside a droplet combustion apparatus within the Combustion Integrated Rack in the station's Destiny module, managed by NASA's Glenn Research Center. The goal was to map the flammability boundaries of liquid fuels and to test fire suppressants for spacecraft. The station's suppressant is carbon dioxide, and the question on the table was how well it actually works when there is no convection to help it. The method was straightforward. Deploy a single droplet of fuel, 1.5 to 5 millimeters across, in a controlled atmosphere. Ignite it. Watch it burn. Vary the conditions. The fuels were N-heptane and methanol. The atmospheres were built from nitrogen, helium, carbon dioxide, and xenon, at oxygen fractions between 10 and 40%, at pressures from 7/10 of an atmosphere to 3 atmospheres. Combustion theory at the time recognized exactly 2 ways a droplet flame could end. The first is diffusive extinction, which happens with a small droplet in a high oxygen atmosphere. The reaction runs out of fuel surface to work with, and the flame goes out. The second is radiative extinction, which happens with a large droplet in low oxygen. The flame loses heat to its surroundings faster than the reaction can replace it, and it cools below the temperature at which it can sustain itself. Both were assumed to be followed by the same thing: pure evaporation. Flame out, fuel evaporates slowly into the surrounding gas, nothing further happens. This was not a controversial assumption. It was the settled understanding of a field more than a century old. In Flex, large heptane droplets burning in ordinary air at 1 atmosphere did something else. The visible flame extinguished by radiative loss, exactly on schedule, exactly as the theory said it would. And then the droplet kept shrinking. Not evaporating at the slow rate evaporation would produce, but shrinking at a steady rate that followed the classical mathematical law of droplet burning, the same law that had described it while it was on fire. It continued that way for many more seconds, with no flame visible to any camera aboard the station, before undergoing a second extinction at a finite diameter. The droplet was still burning. There was simply nothing to see. It is worth understanding how much work went into ruling out the boring explanations first, because a shrinking droplet with no visible flame has several mundane possible causes, and every one of them had to be eliminated. Pure evaporation was the obvious candidate, and it failed on rate. Evaporation into a still gas is much slower than what the cameras were recording, and it does not follow the same mathematical law. Instrument error was considered and rejected because the shrinkage was measured optically and repeatedly across many runs with different fuels and different atmospheres. The support fiber holding the droplet was examined as a possible heat path and was in fact reduced in thickness from 80 micrometers to 40, precisely because the thicker fiber was found to disturb the droplet near extinction. The team's own account of how they eliminated the alternatives has a bluntness that rarely survives into a published paper. Low heat release rate, quasi-steady burning, a second extinction, lower activation energy, passes the duck test, they wrote. It must be cool flame-supported combustion. The numbers from a single run tell the story better than a summary can. Test Flex 500, conducted on the 14th of March 2013, burned heptane in air at 21% oxygen. The droplet began at 3.61 millimeters across. The hot flame went out when the droplet had shrunk to 2.838 millimeters. And then the droplet kept burning, invisibly, at a measured rate of 0.366 square millimeters per second, all the way down to 1.146 millimeters before the second extinction finally stopped it. Between those two diameters, a fire was burning aboard the International Space Station that no instrument in the module could see. The temperature involved is what makes this so difficult to accept. A growing spherical diffusion flame in near-still air extinguishes at roughly 1200 Kelvin, about 927 degrees Celsius. The cool flame's temperature was inferred from the chemistry of ignition delay at around 700 Kelvin. That is roughly 430 degrees Celsius. It is cooler than the self-cleaning cycle of a domestic oven. It is a temperature at which no flame was believed capable of sustaining itself at all. Cool flames themselves were not new. They had been known since the 19th century. But they had always been a pre-mixed phenomenon, fuel and oxidizer already mixed together before ignition, and they had always been a precursor. The canonical sequence was cool flame first, hot flame second. That transition is the chemistry behind engine knock, and it has been studied intensively for a century precisely because it damages engines. Flex inverted the sequence completely. Hot flame, then cool flame. In a diffusion flame rather than a pre-mixed one. Self-sustaining, steady, and measurable. More than 50 years of previous microgravity combustion research had never seen it, and the reason is almost banal. Drop towers, the standard laboratory tool, in which an experiment is dropped down a shaft to produce brief weightlessness, give roughly 5 seconds. Parabolic aircraft flights give 20 or 30. The cool flame stage alone can last anywhere from 5 to 60 seconds. Every previous experiment had ended while the invisible burning was still going on, and the apparatus had been recovered from the bottom of a shaft with a droplet that was smaller than expected and no explanation for why. The phenomenon required a permanently crewed space station to exist long enough to be observed. There was no shortcut. Niagam's own presentation slides on the work record, without further comment, that the paper published after critical reviews from skeptical reviewers. It is a small line, and it says everything about what it is like to report a result that contradicts a century of settled understanding. The consequences run in two directions. For spacecraft fire safety, the implication is direct and unwelcome. A fire aboard a vehicle may appear extinguished, to the crew's eyes, to the cameras, to every detector that looks for visible flame, while cool flame combustion continues invisibly, producing partially oxidized fuel along with carbon monoxide and formaldehyde. Those products can reignite. Reignition has been demonstrated in the laboratory with decane. This changes what a fire detector needs to sense, and it changes how long a compartment must be treated as hazardous after a fire has apparently been put out. There is a useful terrestrial analog for what this behaves like. A smoldering solid, a mattress, a bale of hay, a compost heap can burn for hours or days without flame, consuming fuel slowly at low temperature, producing carbon monoxide, and then flaring into open fire when conditions shift. Firefighters treat smoldering as a distinct and dangerous state, rather than as a fire that has gone out. What Flex found is that a liquid fuel can enter something functionally similar in a spacecraft, in ordinary cabin air, with nothing to see. For engines on Earth, the same low-temperature chemistry governs a design called homogeneous charge compression ignition, which promises low emissions and roughly 15% fuel savings. The central obstacle to making it work is controlling ignition timing, which is to say, controlling exactly the chemistry that Flex accidentally illuminated. The modeling work that followed had to adjust rate constants to predict the second extinction correctly, and once adjusted, the revised chemistry also improved predictions for entirely separate ground-based experiments that had nothing to do with space. There is one honest limitation that belongs at the end of this. NASA's own internal review of the work states it plainly. The cool flame's presence was inferred and not observed. No instrument aboard the station could image them. The 700 Kelvin figure is derived from chemistry, not measured with a thermometer. A follow-on investigation was proposed specifically to build the capability to see what had been found, which is a peculiar position to end up in. A fire aboard an inhabited spacecraft can look, to the eye and to every camera in the module, exactly like a fire that has been put out, while it continues to burn and to fill the air with something that will light again. An invisible flame is at least explicable once somebody finds it. The next entry took 3 months to explain, and it was solved by a man hitting his own spacecraft. Number 15. The Fireflies outside Friendship. 7. On the 20th of February 1962, John Glenn became the first American to orbit the Earth. The mission was Mercury Atlas 6. The spacecraft was called Friendship 7, and it was small, a cone barely large enough to contain a seated man, with a single window. He flew 3 orbits, each lasting 88 minutes and 29 seconds, in an elliptical path with an apogee of about 162 miles and a perigee of about 100. The whole flight lasted 4 hours, 55 minutes, and 23 seconds. His backup for that mission was a Navy test pilot named Scott Carpenter, and that fact matters enormously to how this story ends. The sighting came as Friendship 7 met its first orbital sunrise over the Pacific approaching Australia, 1 hour and 15 minutes and 57 seconds into the flight. What Glenn said is preserved in the transcript, and it is considerably better than any of the retellings that have grown up around it. "This is Friendship 7, he said. "I'll try to describe what I'm in here. I am in a big mass of some very small particles that are brilliantly lit up like they're luminescent. I never saw anything like it. They round a little, they're coming by the capsule, and they look like little stars. A whole shower of them coming by." 9 seconds later, he added detail. "They swirl around the capsule and go in front of the window, and they're all brilliantly lighted. They probably average maybe 7 or 8 feet apart, but I can see them all down below me, also." The response from the ground is revealing, and it is the part of this exchange that almost never gets quoted. The capsule communicator did not ask what they looked like. He did not ask how many there were. He asked one question. "Roger, Friendship 7. Can you hear any impact with the capsule? Over." The instinct in mission control was not wonder. It was structural concern. A man was in orbit inside a vehicle nobody had flown before, surrounded by an unknown quantity of unknown material, and the only thing worth establishing in that moment was whether the material was hitting him. Glenn answered it directly. Negative, he said. "They're very slow. They're not going away from me more than maybe 3 or 4 miles per hour. They're going at the same speed I am approximately. They're only very slightly under my speed." Over. Then, a moment later, they do have a different motion though from me, because they swirl around the capsule and then depart back the way I am looking. And then, 13 seconds after that, with nothing coming back, are you receiving? Over. It is worth being precise about what is not in that transcript, because the popular version of this story has accumulated 3 details that Glenn did not supply. He does not use the word fireflies. He does not say thousands. And he does not describe a color. All 3, the name, the number, and the greenish-yellow tint, come from later recollections and retrospective summaries, including NASA's own. They may well be accurate. Glenn did eventually describe them as looking like fireflies, and the count and color are entirely plausible. But they are not what he said at the time. And what he did say is stronger. "I never saw anything like it. They look like little stars, 7 or 8 feet apart. And a man alone in orbit, 300 kilometers above the Pacific, asking whether anyone on Earth can still hear him. His own first interpretation was that something had gone wrong. He briefly thought either that the spacecraft was tumbling or that he was somehow looking into a star field. A longer look out the window ruled out both, and he became certain the particles were streaming past him from somewhere ahead of the capsule. On the ground, the fear was more specific and much more serious. Some in mission control worried that the heat shield might be disintegrating. That was not an abstract anxiety on that particular flight. Later in the same mission, a separate telemetry indication suggested that the heat shield and landing bag had come loose, a condition that, if real, meant Glenn would not survive re-entry. It is why he was instructed to retain the retro-rocket package strapped over the shield, rather than jettison it, in the hope that the straps would hold the shield in place long enough. He came down through the atmosphere, watching flaming pieces of the retropack tear past his window, not knowing whether they were the retropack or the shield. So when a man in that vehicle reported an unidentified cloud of particles streaming past him, the question of whether his heat shield was coming apart was not a theoretical one. Here is what it was actually like to be there. The capsule is in darkness. It has been for the better part of 40 minutes, and his eyes have adjusted to it. The Earth below is a black absence with no horizon to speak of, and the only light in the cabin comes from the instrument panel. Then the Terminator arrives, and it arrives fast. Orbital sunrise is not a gradual thing, it is a line of light traveling at 8 kilometers a second, and it crosses the spacecraft in a moment. The sun comes up over the curve of the planet, and everything outside the window turns on at once. And what turns on is not the Earth. It is a field of small, bright objects, hanging in space all around the capsule, lit hard from one side, drifting past the window at something close to walking pace. They are not falling. They are not streaming past at orbital speed the way debris would. They are keeping station with him, 7 or 8 feet apart, extending outward and downward past the edge of the window and further than he can see. Some of them curl around the capsule and pass back the way he came. He watches them for a while. Then he reaches for the radio and starts describing them, carefully, in the plainest language he can manage, because there is nothing else he can usefully do, and because describing things accurately is the job. The answer arrived 3 months later, and it arrived because a man hit his own spacecraft. Scott Carpenter flew Mercury Atlas 7, spacecraft Aurora 7, on the 24th of May, 1962. 3 orbits, splashdown after 4 hours, 56 minutes and 5 seconds, some 250 miles off target, northeast of Puerto Rico, after a long enough gap in communications that a national television audience spent close to an hour believing he might be dead. He flew that mission for an unhappy reason. Deke Slayton had been assigned to it and was grounded that March for a minor heart irregularity, an arrhythmia that ended his chance at a Mercury flight and kept him on the ground until 1975. NASA passed over the backup, Wally Schirra, and assigned Carpenter instead, because Carpenter had been Glenn's backup and had trained on exactly this flight profile. Which means the man who flew Aurora 7 was the man who had spent months preparing to fly Friendship 7. He had heard Glenn's description. He had thought about it. There is something worth pausing on in that arrangement. The backup pilot in an early spaceflight program trained for a mission he expected never to fly. He learned the vehicle, the profile, the timeline, and the contingencies as thoroughly as the prime crewman, and then he watched somebody else do it. What that produced, in this case, was a second observer who arrived in orbit already carrying a specific unanswered question, already knowing exactly where in the flight it would appear, and already having had 3 months to consider what he might do about it. The redundancy that exists to cover illness and injury also, occasionally, produces the person best placed to solve a problem. Carpenter saw the same particles. He called them snowflakes rather than fireflies. And then he did the thing that solved it. He struck the wall of his capsule. More flakes showered into view. He struck it again, and more appeared. His report was matter-of-fact and entirely unmystical. I can wrap the hatch and stir off hundreds of them. The answer was frost. Tiny white flakes of ice clinging to the outside of the spacecraft skin. Condensation collected on the exterior as the capsule passed through the freezing orbital night and froze there, building up a thin layer over the course of 40 minutes of darkness. When the spacecraft came back into direct sunlight, the flakes broke free, drifted alongside at very nearly the same orbital velocity, which is precisely Glenn's 3 or 4 miles per hour of relative motion, and were lit brilliantly against the black of space by a sun that had just risen. The optical geometry that makes this work is worth understanding, because it recurs elsewhere on this list. The flakes were not brighter at sunrise than at any other moment. They were simply the only thing being lit. At orbital sunrise, the spacecraft crosses into sunlight while everything below and behind it is still in shadow, which means for a period of a few minutes there is a lit object surrounded by darkness, with no competing illumination anywhere. Anything small and reflective near the capsule becomes, briefly, the brightest thing in the sky. The same arrangement is why noctilucent clouds are only visible at twilight, and why a satellite crossing overhead after sunset is visible from the ground while the observer stands in the dark. Glenn did not see the fireflies at sunrise because sunrise created them. He saw them because sunrise was the only time they could be seen. One genuine dispute survives and should not be smoothed away. There are 2 accounts of where the water came from. The classic version, derived from Carpenter's experiment, says the frost formed on and shed from the spacecraft's exterior skin. A second version attributes the particles to ice crystals venting from the environmental control system's heat exchanger. These are not entirely incompatible. Vented vapor freezing onto the hull and later shaking loose would satisfy both, and the honest formulation is that the Fireflies were frost and ice associated with the spacecraft itself, most probably accumulated on the exterior, with the cooling system a likely source of the water. What makes this the first anchor of this list is not the answer. It is the shape of the whole episode. A man saw something he could not explain. He described it accurately, out loud, live, on an open channel, without embellishing it and without speculating about what it might mean. Mission Control asked the one question that mattered for his survival. And 3 months later, the program's answer to the mystery was to send up the next man, who had listened carefully to the first man's description and who thought of something to try. He did not bring an instrument. He did not run a theory. He hit the wall of his own spacecraft with his hand to see whether the mystery outside would answer, and it did, immediately, and the question was closed. This is the template, and every entry that follows on this list conforms to it, or fails to. An observation is made honestly. It is reported without decoration. It is investigated by people who assume there is an answer. And it either yields one or it does not, and in the cases where it does not, the honest thing is to say so and stop. What corrodes that process is not mystery. It is the impulse to fill a gap in the record with something more satisfying than a gap. There is one footnote worth adding. The 1983 film adaptation of The Right Stuff gave the Fireflies a mystical treatment, staging them as something numinous and possibly alien. That scene is widely blamed for why the mystery persists in public memory decades after Carpenter dissolved it. The real story, a careful observer, a worried flight director, and a backup pilot who solved it by knocking, has never had anything like the same reach. That answer arrived in 3 months. Some of the things on this list took decades, and some of them arrived entirely by accident, in a field in Minnesota, while somebody was fixing a cable. Number 14. The volcano caught in the act. NASA astronaut photograph ISS-020, frame 9048, was taken on the 12th of June 2009 at 16 minutes and 14 seconds past 2200 hours Greenwich Mean Time. The camera was a Nikon fitted with a 400mm lens. The altitude logged for the spacecraft was 337 kilometers. It is one of the most scientifically valuable photographs ever taken by a human being in orbit, and it exists because a space station happened to be in exactly the right place for about 60 seconds. The subject is Sarychev Peak, at the northwestern end of Matua Island in the central Kuril Islands, northeast of Japan. It is an andesitic cone built inside a caldera 3 to 3.5 kilometers wide, capped by a crater 250 meters across with very steep walls. The island's high point is 1,496 meters. Matua is about 12 kilometers along its long axis, and it has been essentially uninhabited since the late 1990s, though before 1945 it held a Japanese army base of up to 4,000 people, and the concrete remains of that occupation are still there under the ash. Activity began on the 11th of June 2009 and became one of the largest historical eruptions in the Kurils. Monitors recorded an energetic phase running from the 11th to the 16th, with more than 10 large explosions, later classified as a 4 on the Volcanic Explosivity Index. The previous explosive eruption at the site had been in 1989, 20 years earlier. The totals are substantial. 1.4 square kilometers of newly formed land, an island that grew while people watched. More than 8 square kilometers covered by pyroclastic flows. a minimum erupted volume of about 0.4 cubic kilometers, which is very roughly 160,000 Olympic swimming pools of rock, launched into the air and redeposited across an island 12 kilometers long. When investigators finally landed on the 26th to 28th of June, fumaroles escaping the still hot flows were reaching around 500 degrees Celsius. What the photograph froze is a set of distinct early eruption phenomena that almost never appear together in a single frame, and that is why volcanologists prize it. There is the main eruption column, one of a series that rose that day, a mixture of brown ash and white steam. It is rising vigorously enough that the steam takes on a bubbling, boiling texture rather than the smooth billow of a slower plume. Capping it is a smooth white pileus cloud. This is a specific and transient thing, a slab of clean, moist air being shoved upward ahead of the rising column, cooling as it goes, and condensing into a lens-shaped cap that sits on top of the ash like a lid. Below it is a distinct ring, sometimes called a cloud skirt. And in the photograph, the darker ash column is already visible, starting to punch through the pileus from underneath, which means the cap was probably visible for only a few minutes in total. The column's geometry is clean and vertical, which indicates essentially no wind shear at that moment. That is worth appreciating because satellite images taken 2 and 3 days later show the same plume badly sheared and smeared across the Pacific in a long grey streak. What the photograph caught was not the eruption's normal appearance. It was the eruption during the brief window when the atmosphere was leaving it alone. Below and around the summit, there is a dense grey cloud hugging the ground and traveling radially outward from the vent. Analysis identifies at least 2 or 3 distinct, differently colored clouds moving along the surface. One of them, an unmistakable light-colored pyroclastic flow, narrowing as it crosses the island. A pyroclastic flow is a ground-hugging avalanche of hot gas and volcanic debris, and it is the phenomenon that kills people in eruptions. It moves at highway speeds, and it is several hundred degrees hot. The column's shadow falls to the northwest, across the cloud deck. Low-level ash spreads near the ground, and low stratus wraps the volcano's lower slopes so completely that only about 1.5 kilometers of Meteors' coastline is visible anywhere in the frame. The luck involved in obtaining this image is difficult to overstate. The station passed overhead during an explosion rather than between them. There was no shearing wind to deform the column. There was a break in an otherwise complete overcast that happened to sit directly over the vent. And there was a 400mm lens already mounted on a camera, which is not the lens anyone keeps on by default. The pass yielded 29 still images over roughly a 1-minute interval. From those frames, NASA later built animations. One enthusiast produced a red and blue stereo anaglyph of the plume from the parallax between images, which NASA ran as its astronomy picture of the day on the 25th of June, meaning that for a brief period, the general public could look at a volcanic eruption in 3 dimensions from orbit. There is a near miss in the record that puts the whole thing in perspective. On the night of the 11th to 12th of June, a research ship passed close to Meteor Island. Nobody aboard noticed an eruption. The photograph is credited to the Expedition 20 crew rather than to a named individual, which is NASA's standard practice for crew Earth observation imagery, and which has the odd effect of leaving one of the most reproduced photographs in the agency's collection formally anonymous. The crew aboard on the 12th of June 2009 was Gennady Padalka, Michael Barrett, Koichi Wakata, Roman Romanenko, Frank DeWin, and Robert Thirsk. Expedition 20 was the first 6-person resident crew in the station's history, and it had only been at full complement since late May, meaning the photograph was taken during the first few weeks in which 6 people had ever lived aboard the station simultaneously. 2 of those names appear elsewhere on this list. Michael Barrett and Robert Thirsk, both physicians, spent that same expedition noticing that they were having increasing difficulty reading their own research procedures. What they did about that observation is the subject of a later entry. The photograph also started a scientific argument that has never been settled, and it is the reason this entry belongs on a list of things that could not immediately be accounted for. NASA's Earth Observatory appended an editor's note after publication because the image had generated debate among meteorologists, geoscientists, and volcanologists. The disagreement is about a specific feature, the clean circular hole in the cloud deck surrounding the plume. The clouds are not merely parted. There is a well-defined gap, roughly circular, centered on the volcano. 3 explanations remain on the table, and none of them has won. The first is that it is a coincidence, a meteorological island wake, where a marine layer cloud sheet drifts over an island surrounded by cool water. The moist low-level air is forced upward into drier air above, and the cloud evaporates. The resulting hole can extend a long way downwind and sometimes curls into a train of vortices. The strongest evidence for this reading is that a broader image taken from the station on the same day shows a series of similar holes aligned along the entire Kuril chain over islands that were not erupting. The second is that the eruption's shockwave shoved the overlying atmosphere upward and either created the gap or widened one that was already there. The third is downdraft. As a column rises, air flows down around its flanks. One description compares it to water running off the back of a surfacing dolphin. Sinking air warms as it descends, and warming air evaporates its cloud. The Smithsonian's assessment describes the hole as likely in part meteorological, while noting that the eruption-driven explanation has many adherents. That is where it has stood for more than 15 years. One thing this photograph cannot tell us is how high the column went. That deserves stating plainly, because a figure is often attached to it that does not belong there. No clear analysis of the plume height in this specific image has ever been published. What is documented is the eruption as a whole. Ash clouds during the 11th to 16th of June rose to between 8 and 16 kilometers, and by some estimates as high as 21. 16 kilometers is about 1.5 times the cruising altitude of an airliner. 21 is roughly double it. The plume's reach was continental. Ash stretched 1,500 kilometers to the north and west, and more than 3,000 kilometers to the east. Ash was detected 2,407 kilometers east-southeast of the volcano. An instrument aboard NASA's Aurora satellite tracked the sulfur dioxide plume across the North Pacific as far as Alaska, and it was tentatively judged the largest sulfur dioxide event of 2009 to that point in the year. There is a reason a photograph like this is worth more to science than a satellite image of the same event, and it comes down to what a human being with a camera can do that an automated system cannot. A weather satellite in geostationary orbit sees the Kurils continuously, at fixed intervals, from directly above, at a resolution measured in kilometers. It would have recorded the eruption as a spreading grey blot. What it could not do was recognize, in the moment, that a hole had opened in the cloud deck over an erupting volcano with no wind shear present, reach for a long lens, and take 29 frames at an oblique angle that captured the column's vertical structure, its cap cloud, its shadow, and the flows moving across the ground beneath it. Crew Earth observation exists precisely because a trained person looking out of a window makes judgments that no imaging schedule can anticipate. The practical consequence was aviation. The Kuril Islands sit beneath one of the busiest air corridors in the world, and volcanic ash and jet engines are famously incompatible. Diversions during the eruption reportedly cost as much as $100,000 per flight. So, a photograph obtained by coincidence in a 60-second window of an eruption that a passing ship failed to notice, which shut down air routes across the North Pacific, and which contains a feature that 3 separate scientific disciplines have been arguing about ever since. That column was punching upward through the sky. The next entry falls through it, and the people best placed to watch it happen are above it. Number 13. Meteors falling beneath the window. The geometry of this entry is the entire point of it, so it is worth establishing carefully before anything else. Meteors burn up in what atmospheric scientists call the meteoric region. The luminous portion of the trail, the part a person on the ground actually sees, typically runs from about 120 kilometers altitude down to about 80. Very fast meteors can begin glowing above 120. Below 80, most of them are gone. The International Space Station orbits at roughly 400 kilometers. The station is therefore 3 to 5 times higher than the layer where meteors die. And that single fact rearranges the experience completely. Crews watching a meteor shower from orbit do not look up. They look down. The streaks appear beneath them, against dark ocean, against the tops of clouds, against the orange grid of city lights and the black gaps between cities. There is no sensation of something falling toward the observer, because nothing is. A meteor seen from orbit is a brief horizontal scratch of light drawn across the top of the planet, lasting a fraction of a second, and then it is not there. The photograph that made this famous was taken by NASA astronaut Ron Garan on the 13th of August 2011 during Expedition 28. He caught a Perseid while the station was over China, roughly 400 kilometers northwest of Beijing. He posted it the following day with a caption that has since become close to a definition of the whole genre. "What a shooting star looks like from space," he wrote, "taken yesterday during Perseid meteor shower." NASA has run that image as its astronomy picture of the day at least 3 separate times, under the title Perseid Below. The word "doing the work" in that title is the last one. The speeds involved are what make these objects visible at all, and they are extreme even by the standards of this list. Meteoroids strike the atmosphere at anywhere from about 11 kilometers per second to about 72, depending on whether Earth is catching up with them or running into them head-on. The Perseids, which are debris shed by Comet Swift-Tuttle, arrive at 59 kilometers per second. That is roughly 210,000 kilometers per hour, and about 170 times the speed of sound at sea level. The Geminids, which come from an unusual object called Phaethon, an asteroid that behaves partly like a comet, are comparatively slow at 35 kilometers per second. For scale, the station itself is moving at about 7.7 kilometers per second, which is fast enough to cross a continent in 10 minutes. A Perseid is closing on the atmosphere roughly 8 times faster than that. None of these objects is large. The particles producing a typical visible meteor are the size of a grain of sand or a small pebble. What makes them light up the sky is not their mass, but the energy they carry, and energy scales with the square of velocity. A sand grain at 59 kilometers per second carries more energy than a rifle bullet. The station carries a dedicated instrument to study them, which is a detail most people do not know. The meteor investigation is a high-sensitivity, high-definition camera with a visible light spectroscopy capability, installed in the Window Observational Research Facility rack in the Destiny Laboratory module and pointed straight down through the nadir window during orbital night. Its purpose is elegant. By capturing the spectrum of a meteor's light, rather than just its image, it can derive the size, the density, and the chemical composition of the object that made it. It reads what a grain of comet dust is made of by the color of its destruction. The material has been traveling unchanged since the formation of the solar system, and the only opportunity to analyze it arrives during the 2 seconds in which it is being destroyed. The instrument made its first observations on the 7th of July 2016. A widely published composite was assembled from frames taken on the 30th of July that year during the Delta Aquariid shower. It is worth noting that the payload was destroyed twice in launch failures before it finally reached orbit. Two separate cargo vehicles carrying two separate copies of the hardware, both lost. Crews have also photographed the Lyrids from the station, and the Perseids remain the most frequently captured shower simply because August offers the best combination of rate and orbital geometry. The observing conditions are unusual in one respect that has nothing to do with altitude. From the ground, a meteor shower is spoiled by cloud, by moonlight, by streetlight, and by having to wait for the sky to darken. From the station, orbital night arrives every 92 minutes, whether anyone is ready for it or not, lasts about 35 minutes, and is absolutely dark. A crew member photographing a shower gets a fresh night sky 16 times a day. There is a caution that belongs in any honest account of meteors observed from the station, and it applies to a large share of the most spectacular footage in circulation. A great deal of the dramatic fireball imagery captured from the cupola is not natural at all. It is re-entering hardware. Spent rocket stages, defunct satellites, and discarded cargo vehicles come home regularly, and they break up in long, slow, fragmenting trails that look considerably more impressive than a natural meteor. A natural meteor is over almost before it registers. A re-entering upper stage can cross a substantial fraction of the sky, shedding glowing pieces the whole way. The two are routinely confused, including in captions that ought to know better. As for whether the station itself is at risk from the same material, the answer is yes, and the engineering literature is direct about it. Micrometeoroid and orbital debris impact is described as the top mission risk for crewed spacecraft. The primary defense is an idea of considerable elegance called a Whipple shield. Rather than trying to build a wall thick enough to stop a hypervelocity particle, which would be impossibly heavy, a Whipple shield places a thin sacrificial bumper some distance in front of the real hull. The incoming particle strikes the bumper and is not stopped by it. It is shattered. Both the particle and a section of the bumper are converted into an expanding cloud of much smaller fragments and vapor, which then spreads out over the gap and arrives at the hull as a diffuse spray rather than a concentrated point. The energy is the same. The area over which it is delivered is vastly larger, and the hull survives. NASA and the European Space Agency later developed stuffed Whipple shields, which sandwich layers of ceramic fabric and Kevlar between the bumper and the rear wall to break up the fragment cloud further. Shielding is not applied uniformly across the station because every kilogram of shielding is a kilogram that had to be launched, and the risk is modeled surface by surface with a dedicated code. The defenses do not always hold. On the 14th of December 2022, sensors detected a coolant leak from the Soyuz MS-22 spacecraft docked at the station. Video showed a spray of coolant venting into space, freezing as it went. After joint analysis and ground hypervelocity testing, NASA and Roscosmos concluded that a micrometeoroid had punched a hole about 1 millimeter across in the external coolant loop, with about 4 millimeters of associated damage to the radiator. A hole a millimeter wide. The consequence was that the spacecraft could no longer safely carry its crew home, because without coolant, the cabin temperature during re-entry could not be guaranteed. The vehicle was returned to Earth empty, and a replacement Soyuz was launched to bring the crew down. 3 people were left in orbit without a functioning ride home because something the size of a grain of sand hit a pipe. Speculation in the press at the time held that the impactor had been a Geminid, since the leak occurred close to the shower's peak. That was never confirmed by either agency, and it should not be asserted. What is clear is the wider point. Shower meteoroids are only a small addition to the constant background of sporadic material, which dominates the natural flux, while orbital debris dominates the overall risk at station altitude. To close this entry, It helps to know what the largest recent version of this looks like from the ground. On the 15th of February 2013, at 9:20 in the morning local time, an asteroid roughly 18 to 20 meters across and weighing somewhere between 10 and 13,000 tons entered the atmosphere over Chelyabinsk Oblast in Russia. It came in at about 19.2 kilometers per second on a shallow 18-degree trajectory, and it detonated at an altitude of about 30 kilometers. The energy released was roughly 500 kilotons of TNT, more than 30 times the yield of the Hiroshima bomb, delivered about 3 times higher than a cruising airliner. Nearly 1,500 people were injured, overwhelmingly by glass blown inward by the shockwave. Nobody was struck by the object itself. Over 7,200 buildings were damaged. 2 details about that event are worth carrying away. It detonated at 30 kilometers, well below the 80 to 120 kilometer band where ordinary meteors are destroyed, which is exactly why its shockwave reached the ground. And it arrived from the direction of the sun, which meant it was never detected in advance by anyone. It was the largest airburst since Tunguska in 1908, and it came with 0 warning. Meteors leave their mark on the sky in another way too. The dust they shed as they burn does not simply vanish, it stays up there, and it becomes the seed for something else entirely. Number 12. The clouds that live above the sky. Noctilucent clouds form between 76 and 85 kilometers above the ground, near the boundary between the mesosphere and the thermosphere. To put that in the only terms that make it comprehensible, ordinary weather clouds top out around 12 to 18 kilometers. The anvil of a large thunderstorm, the highest cloud most people will ever see, reaches perhaps 18. These sit roughly 5 to 7 times higher than that. They are, by a very wide margin, the highest clouds in Earth's atmosphere, and there is nothing above them but progressively less air. Seen from satellites looking down over the poles, they are called polar mesospheric clouds. Noctilucent, literally night shining, is the ground observer's name for the same ice. Both names describe the same phenomenon, and the phenomenon is genuinely peculiar in almost every respect. They are made of water ice, which is unremarkable. The crystals, however, are extraordinarily small, on the order of tens of nanometers across. That size is why they scatter light preferentially at the blue end of the spectrum, and why they appear silvery and electric rather than white and soft. A noctilucent cloud does not look like a cloud. It looks like a photographic negative of one, or like fine rippled filaments of light lying across the twilight. The ice deposits directly from vapor onto condensation nuclei, and the identity of those nuclei is one of the better facts in atmospheric science. They are believed to be meteoric smoke, nanometer-scale residue left over from meteoroids that burned up in exactly the layer described in the previous entry. Laboratory and modeling work identifies sodium bicarbonate, a component of that smoke, as a particularly effective nucleus. Below about 126 Kelvin, any charged meteoric smoke particle will serve as an ice nucleus regardless of its size. Which means the highest clouds on Earth are, in a very direct sense, built on the ashes of the solar system. Water freezes onto the burnt remains of comet dust, and the result is visible from the ground on summer evenings. The conditions required are extreme, and one of them is genuinely counterintuitive. The summer polar mesopause is the coldest place in Earth's atmosphere. It reaches 120 to 130 Kelvin, about 145 to 155 degrees below 0 Celsius. That is colder than the surface of the Antarctic in winter by an enormous margin, and it is colder than anything else in the atmospheric column. Read that again with attention to the word summer. The mesosphere is coldest over the summer pole, not the winter one. In July, the air 80 kilometers above the Arctic is the coldest air on the planet. The cause is upwelling. The atmosphere has a large-scale overturning circulation that rises over the summer pole, and rising air expands and cools. That adiabatic cooling drives the summer mesopause down to temperatures the winter mesopause never reaches. Ice formation requires temperatures below a frost point of roughly 145 to 150 Kelvin, and it works best around 130, which the summer pole obligingly provides. From the ground, the viewing conditions are just as narrow. They are visible only from about 50 to 65 degrees of latitude, north or south, and only during twilight, with the sun between 6 and 16 degrees below the horizon, optimally about 10. Above 6 degrees, the sky is still too bright to see them against. Below 16, the layer 80 kilometers up has itself passed into shadow, and there is nothing left to light. They typically appear within 15 to 20 degrees of the horizon along the twilight arch. That narrow window is the same optical arrangement that made Glenn's Fireflies visible, an object lit by a sun that has already set for the observer. It is the only way to see something that faint. They enter the historical record in 1885, and the circumstances of that entry are genuinely disputed in a way that is worth handling carefully. Krakatoa erupted in August 1883, injecting an enormous quantity of material into the upper atmosphere and producing vivid twilights worldwide for years afterward. Robert Leslie recorded a noctilucent cloud sighting in July 1885 from Southampton. The German astronomer Otto Jesse coined the term in 1887, ran the first systematic observing program, and holds the first published photographs, though an observer in Moscow appears to have photographed them slightly earlier, in 1885 or 1886. The obvious inference is that Krakatoa caused them. That inference is repeated constantly, and it is not established. Here is what careful historical work does establish. Before 1885, noctilucent clouds were never described in the literature. The related phenomenon of unusually bright nights was well known throughout the 19th century and was written about at length, but no observer before 1885 described structures identifiable as these clouds. A note by the painter Robert Leslie, apparently describing an 1884 observation, is judged by the historical literature to be insufficiently reliable to settle anything. So 2 readings remain live, and neither has won. Either Krakatoa genuinely triggered the first displays, or the eruption simply caused an unprecedented number of people to spend 2 years staring at twilight skies, and the clouds had been there all along, unremarked. The specific mechanism usually proposed, volcanic dust acting as the condensation nuclei, is not supported by modern work, which points firmly at meteoric smoke instead. That weakens the causal story without settling the historical one. There is a further wrinkle in the historical question that deserves mention, because it illustrates how hard this kind of problem is. Absence of a description in the literature is not the same as absence of the phenomenon. 19th century observers were not systematically watching the twilight sky at high latitudes in midsummer, which is the only time and place these clouds appear. Midsummer at 55 degrees north means twilight that never fully ends, and a sky that never gets properly dark, conditions under which most astronomers of the period simply stopped observing and waited for autumn. It is entirely possible that the clouds were present and that nobody with the vocabulary to describe them was looking. It is equally possible that they genuinely were not there. The record cannot distinguish between the two, and honest treatments of the question say so. NASA eventually flew a mission dedicated entirely to these clouds. The Aurora of ice in the Mesosphere satellite launched on the 25th of April 2007 from a Pegasus rocket dropped from beneath an aircraft into a sun-synchronous orbit at 600 kilometers. It carried 3 instruments, a multi-camera ultraviolet imager providing hemisphere-scale coverage of the clouds, a solar occultation experiment, that began science observations on the 14th of May, and a cosmic dust experiment to measure the incoming meteoric material that supplies the nuclei. It was designed for a 26-month mission. It ran for nearly 16 years. Its battery had been in decline since 2019 and finally failed on the 13th of March 2023, at which point the spacecraft could no longer reliably receive commands and NASA ended support. Its data appeared in 379 peer-reviewed papers, a return on a 2-year mission that is difficult to overstate. And what all that observation has established is that the clouds are changing. The foundational argument was published in 1989 and holds that noctilucent cloud brightness is a sensitive indicator of the water content of the summer mesopause. The chemistry connecting that to human activity is direct rather than speculative. Methane oxidized in the middle atmosphere yields water. Each methane molecule can produce up to 2 water molecules. Methane released at ground level does not simply sit there. A fraction of it works its way up and is converted into water vapor 80 kilometers above the Arctic. Estimates from the mission's science team put the increase in mesospheric water vapor at about 40% since the late 1800s. That has more than doubled the amount of ice that forms up there. The observational trend matches the chemistry. The displays are brighter than they were. They are more frequent. They are being seen at lower latitudes than any historical record contains. They have occasionally been observed in daylight. There is a reinforcing effect on top of that, and it is one of the more counterintuitive consequences of a warming lower atmosphere. As the troposphere warms, the upper atmosphere cools. More greenhouse gases trap heat below and radiate it away more efficiently above. So the mesosphere gets colder at the same time as it gets wetter, and both changes push in the direction of more ice. The consequence is worth stating in plain terms. A phenomenon that was, on the available record, either rare or entirely absent before the 1880s, is now a routine summer sight across northern Europe and the northern United States. Amateur observers photograph it every year. Whatever the true story of 1885 turns out to be, something in the mesosphere has changed within the span of recorded observation, and the change is in the direction that the chemistry predicts. One honest caveat belongs here. Noctilucent cloud occurrence is strongly modulated by the 11-year solar ultraviolet cycle, with which it is anti-correlated, and separating that natural signal from a long-term trend is genuinely difficult. The trend is real. Its full attribution is still being worked out. From orbit, these clouds resolve the whole question of altitude visually and instantly. Tim Peake photographed them from the station on the 29th of May 2016, and crews had earlier captured what NASA described as the first time-lapse sequence of the phenomenon from orbit on the 5th of June 2012. In those images, the clouds appear as a razor-thin luminous blue thread, riding above the layered orange and red bands of ordinary twilight at the limb, clearly, unmistakably separated from the weather layer by a wide, dark gap. From the ground, the same clouds simply look like unusually high cirrus. It takes being above them to see how far above everything else they actually are. That is the recurring lesson of orbital observation, and it applies to nearly every entry on this list. The phenomenon does not change, but the geometry of looking at it does, and the geometry turns out to have been carrying most of the confusion all along. Those clouds are lit by a sun that has already set. The band of green just above them makes its own light, and it has been quietly obstructing astronomy for as long as there has been astronomy. Number 11. The green band, at the edge of the world. In almost every photograph ever taken from the International Space Station looking sideways across the Earth's limb at night, there is a thin, luminous green line separating the dark planet from the black of space. It is in the background of famous images. It is in amateur snapshots. It is in the corner of photographs taken of something else entirely. Most people who have looked at pictures from the station have looked directly at it hundreds of times without ever asking what it is. It is not aurora. It is not city light. It is not lens flare, and it is not an artifact of the camera. It is airglow, and it is the reason the night sky on Earth is never truly black, even after every star, the moon, and the zodiacal light have been accounted for and subtracted away. Airglow is faint chemiluminescence from the upper atmosphere. During the day, solar ultraviolet light splits atoms and molecules apart. At night, they find each other and recombine, and the energy stored in that separation comes back out as photons. Sunlight absorbed during the day is re-emitted as light after dark. The atmosphere is very slowly returning what it borrowed. The distinction from aurora matters and is frequently muddled. Airglow has no connection to Earth's magnetic field and none to particles precipitating in from the sun. It is not a weak aurora, and calling it one gets the physics wrong in both directions. Aurora is external energy arriving and being deposited. Airglow is stored solar energy being released. They happen to produce light at some of the same wavelengths, which is the entire source of the confusion. The signature emission is the atomic oxygen line at 557.7 nanometers. It is what physicists call a forbidden transition, which does not mean it cannot happen. It means it happens slowly, over a timescale long enough that in denser air, the atom would be knocked out of its excited state before it ever got the chance to glow. That constraint is what confines the emission to a narrow altitude band. The emission peaks in the mesosphere and lower thermosphere, with the layer centered near 97 kilometers and most of the light coming from between 90 and 105. Two production mechanisms compete in the scientific literature: a direct three-body recombination of oxygen atoms and a two-step process that routes the energy through an excited oxygen molecule first. Measurement now generally favors the second, but the branching ratios and rate coefficients remain genuinely disputed. This is an open problem rather than settled textbook material, and anyone who tells you otherwise is compressing. There is more than one layer, and the different layers glow in different colors for different reasons. The mesospheric sodium layer sits at about 90 kilometers and is roughly 10 kilometers thick, at a temperature near 180 Kelvin. Its sodium is meteoric. Atoms ablated from incoming meteoroids and left suspended in a band around the entire planet. It emits the sodium D lines, the same yellow-orange emission that made old streetlights look the color they did. Below about 90 kilometers, sodium recombines into molecules, which gives the layer a sharp lower boundary. That layer has a practical use that is worth knowing about. Major observatories fire lasers tuned precisely to the sodium wavelength up into it, exciting a small patch of sodium atoms into glowing and creating an artificial star at a known position. Adaptive optics systems then measure how the atmosphere is distorting that artificial star and correct for the distortion in real time. Every large telescope image taken with laser guide star assistance depends on a layer of vaporized meteor. Hydroxyl emission dominates the near-infrared airglow from a layer near 87 kilometers, identified in 1950. Nitric oxide, formed from recombining nitrogen and oxygen, contributes further lines. There is no single airglow altitude. There is a stack of them. The brightness numbers are what explain the whole geometry of this entry, and they are more consequential than they sound. At visual wavelengths, airglow measures around 20-second magnitude per square arcsecond at a high-altitude observatory on a moonless night, which puts it in the same range as the total brightness of a pristine natural night sky at solar minimum. Published estimates put airglow's share of that total at roughly 65 to 70%. It is the single largest natural contributor to dark sky brightness. Larger than zodiacal light. Larger than the integrated light of every star in the sky combined. For anyone trying to observe faint objects from the ground, this is the central obstacle, and a worked example makes it concrete. Consider an ideal 10-meter telescope, observing an unresolved 28th magnitude star in good seeing conditions. From the star, about 35 photons per second arrive. From airglow, over the same small patch of sky containing the star, about 3,500 photons per second arrive. The sky is 100 times brighter than the thing being looked at. The star is not hidden behind the glow, it is buried in the noise of it, and the only way to extract it is to observe long enough that the star's signal accumulates faster than the random fluctuation in the background. That single ratio is the reason an 8-meter telescope on a mountaintop needs roughly 40 hours of exposure to reach a depth that the 2.4-meter Hubble Space Telescope reaches in 4. Hubble's mirror is a third the diameter and gathers a small fraction of the light. It wins anyway, by an order of magnitude in efficiency, because it is above the glow. So why is something contributing 2/3 of the sky's brightness invisible to anyone standing on the ground? The answer is entirely geometric. From below, you are looking through a thin emitting shell, nearly face-on. The line of sight passes through perhaps 10 kilometers of glowing gas, and that light is spread across the entire dome of the sky at a surface brightness the dark adapted eye can barely register. It reads as sky rather than as a thing. From orbit, you look tangentially through the limb. The line of sight enters the shell at a shallow angle and runs along the inside of it for hundreds of kilometers before exiting. Identical emission, identical chemistry, identical brightness per unit volume, stacked up by geometry into a discrete, unmistakable green band hugging the horizon. Airglow is not confined to Earth, and the comparisons are instructive. Venus Express detected near-infrared nitric oxide and oxygen night glow in the Venusian atmosphere, and that emission is now the leading explanation for a mystery that had puzzled observers for centuries: the ashen light, a faint glow occasionally reported on the unlit portion of Venus's disk by telescopic observers going back to the 1700s. Generations of astronomers argued about whether it was real, whether it was an optical illusion produced by the bright crescent, or whether it indicated something happening in the Venusian atmosphere. It was the same chemistry Earth performs every night, seen from very far away. And on the 15th of June 2020, the first detection of the 557.7 nanometer green line at Mars was reported, using an instrument aboard a European orbiter observing the Martian limb, looking sideways through the atmosphere at a shallow angle, which is exactly the geometry that station crews use to see Earth's. Mars has the same green band. It took an orbiter looking at the limb to find it, for exactly the reasons described above. The phenomenon was first identified in 1868 by the Swedish physicist Anders Jonas Ångström, who had measured the bright yellow-green line in the auroral spectrum the year before. He did not distinguish airglow from aurora. That separation waited until the 1920s. Simon Newcomb is credited with the first scientific study of airglow as a phenomenon in its own right, in 1901. Aristotle and Pliny both described things that modern historians read as partly aurorae and partly unusually bright airglow nights. The most recent dedicated instrument produced the strangest result in this entry. The Atmospheric Waves experiment launched to the station in November 2023 and was mounted on the station's exterior using the Canadarm2 robotic arm. It was built by the Space Dynamics Laboratory at Utah State University, cost $59 million, and was NASA's first dedicated heliophysics instrument mounted on the station. Its hardware was 4 identical radiometer telescopes staring straight down at the hydroxyl layer 87 kilometers below, mapping temperature perturbations at horizontal scales of 30 to 300 kilometers across a 600-kilometer field of view, capturing 4 infrared images every second. It was switched off in May 2026 after capturing more than 80 million nighttime images over more than 14,000 orbits. What it found is that airglow works as a screen, a projection surface on which weather far below draws itself. Atmospheric gravity waves are ripples that propagate upward through the atmosphere when air is disturbed. A thunderstorm generates them. So does wind flowing over a mountain range. So does a tsunami. They travel upward, and because atmospheric density falls exponentially with altitude, their amplitude grows as they climb. A ripple that is imperceptible near the ground becomes enormous by the time it reaches 90 kilometers. The instrument imaged gravity waves generated by Hurricane Helene in 2024, arriving in the mesosphere. It imaged a near-perfect set of concentric circular waves spreading across Texas and Mexico from a severe weather event on the 3rd of May, 2024. Expanding rings, like something dropped into water, drawn across a glowing layer 55 miles up. A storm on the ground writes itself into a band of light in the upper atmosphere, and there is an instrument on a space station reading it. The scientific value of that is not aesthetic. Gravity waves carry momentum and energy upward from the lower atmosphere into the mesosphere and thermosphere, and they deposit that energy where they break, which affects the circulation of the upper atmosphere, the temperature structure, and ultimately the density of the region that low-orbiting satellites fly through. Atmospheric drag on a satellite depends on the density of the air at its altitude, and that density responds to weather 300 kilometers below. Predicting where a satellite will be in a week requires knowing something about a thunderstorm that happened yesterday. The airglow layer is one of the few places where that coupling can actually be watched happening. It also explains a small, persistent oddity in the photographic record. Astronauts have long remarked that the green band is not smooth. It has structure, ripples, bands, patches of brighter and dimmer emission that shift over minutes. For years, this was largely a curiosity noted in passing. It is the shape of waves arriving from below, made visible because they are compressing and rarefying a glowing gas. The atmosphere makes its own light, and the light turns out to be a record of everything that has happened underneath it. The atmosphere makes its own light. So, it turned out, does a spacecraft, and for about a decade, nobody could work out why. Number 10. The glow that clung to the shuttle's skin. When the Space Shuttle Columbia flew STS-3 in March 1982, the crew noticed something on their own vehicle that nobody had designed, nobody had predicted at that intensity, and nobody could immediately explain. Every surface facing into the direction of travel was wrapped in a thin orange-red luminous layer. Engineers call that the ram direction, the side of the vehicle running into whatever is out there. The glow clung to the skin. It moved with the orbiter. And at the shuttle's lower operating altitudes, it was bright enough to be seen with the unaided eye, without instruments, simply by looking out of a window at the tail. The layer extends about 10 centimeters out from the surface, roughly the thickness of a paperback book stood on end. Its spectrum peaks near 680 nanometers, in the red, and it forms a continuum rather than a set of discrete emission lines. That last detail is more important than it sounds. Most glowing gases emit at specific wavelengths determined by the energy levels of the atoms involved, and those wavelengths function as a fingerprint. Look at the spectrum, identify the lines, identify the substance. A continuum has no such fingerprint. It is a broad smear of light across a range of wavelengths, and it tells you comparatively little about what produced it. The shuttle was surrounded by a glow whose spectrum actively refused to identify itself. Similar anomalies had been reported in rocket experiments as far back as 1958, but nothing at this scale on a crewed vehicle, and nothing anyone had been able to study properly. Working out the mechanism took most of a decade, and the paper that finally settled it has an unusual author list. Of its 7 authors, 2, Richard Hybe and Gregory Harbaugh, were serving NASA astronauts. Crew members co-authoring the physics paper on a phenomenon they had personally helped observe is not a common arrangement, and it says something about how directly this problem sat in the crew's field of view. The accepted explanation is called surface-catalyzed recombination, and it is worth walking through slowly because it is genuinely elegant. In the extremely thin upper atmosphere, a substantial fraction of the oxygen exists as single atoms rather than as ordinary two-atom molecules, because solar ultraviolet light has broken them apart and the air is too thin for them to find each other again quickly. The shuttle, moving at nearly 8 kilometers per second, plows through this atomic oxygen. From the vehicle's point of view, it is not drifting past. It is arriving as a directed stream at hypersonic speed, striking only the surfaces that face forward. Meanwhile, nitric oxide, either from the ambient atmosphere or produced by reactions in the shuttle's own thruster exhaust, is absorbed on the vehicle's surfaces, stuck lightly to them. When an incoming oxygen atom strikes a surface carrying adsorbed nitric oxide, the two combine to form nitrogen dioxide. The molecule that results is electronically excited. It holds more energy than its ground state, and as it lets go of the surface, it sheds that energy as light. The continuum spectrum matches the known nitrogen dioxide recombination continuum, and shuttle mass spectrometer data confirmed high nitrogen dioxide fluxes on RAM-exposed surfaces. The glow is not the atmosphere burning. It is not friction, and it is not heat. It is a chemical reaction taking place on the skin of the spacecraft, at whatever temperature that skin happens to be, powered by material the vehicle is running into. 3 variables control the intensity: local atmospheric density, the angle between the velocity vector and the surface temperature. That second one has a visible consequence. Because brightness depends on the angle at which a surface meets the oncoming stream, the shape of the glow is a direct picture of which way the spacecraft is going. The light maps the motion. It is worth appreciating how strange this looked before the mechanism was understood. A crew in orbit reported that their vehicle was surrounded by light, not reflected sunlight, because the effect persisted on the night side. Not heating, because the surfaces were not hot. Not any onboard light source, because it was outside the windows and clinging to the tail. The spectrum refused to identify itself, and it changed intensity depending on which way the orbiter was pointed and how low it was flying. Everything about that description would sit comfortably on a list of unexplained phenomena, and for several years it effectively was one. The difference between this and the entries on this list that never got resolved is not the strangeness of the observation. It is that a specific, testable chemical hypothesis existed, and that somebody eventually got the chance to test it. The cleanest confirmation of the mechanism was an accident, and it is the kind of accident experimenters spend years trying to design deliberately. During a plasma experiment on STS-39 in 1991, 4 gases were released from the vehicle: nitric oxide, carbon dioxide, xenon, and neon. Enough of the nitric oxide was unintentionally scattered onto the shuttle's tail surfaces that a much more intense version of the glow appeared there. The other 3 gases produced no effect at all. 1 gas, 1 dramatic result, 3 controls that did nothing. If the nitrogen dioxide mechanism was correct, adding nitric oxide should amplify the glow, and adding unrelated gases should not. That is precisely what happened, unplanned, in orbit. The altitude dependence provided a second independent confirmation. Comparing photographs from STS-3 and STS-5, flown at roughly 240 and 305 kilometers respectively, the glow was about 3.5 times brighter on the lower flight. That tracks the steep fall-off in atomic oxygen density with altitude: thinner atmosphere, fewer oxygen atoms arriving per second, less reaction, less light. Atomic oxygen is dense enough to matter for spacecraft materials between roughly 180 and 650 kilometers, with erosion worst at the bottom of that range. Practically, this is a low-orbit phenomenon, and a shuttle altitude phenomenon in particular. And this is the point where the story stops being a curiosity and becomes a genuine problem for science. Shuttle glow is a local foreground. It is an artificial airglow sitting 10 centimeters away from any instrument mounted on the vehicle, produced by the vehicle, moving with the vehicle, and impossible to escape by pointing somewhere else. Any attempt at faint object imaging or spectroscopy from that platform is contaminated by a light source that travels with the telescope. The literature is explicit about the consequences. Anomalous airglow observations made by the Atmospheric Explorer spacecraft have been attributed to spacecraft glow rather than to the atmosphere those instruments were built to measure. Published atmospheric science was contaminated by the skin of the spacecraft doing the measuring, and it took years to establish that this was what had happened. A related case at the Dynamics Explorer spacecraft was traced primarily to hydroxyl forming on the spacecraft surface from ionospheric oxygen and hydrogen, the same category of problem, different chemistry. There is a broader lesson buried in that episode, and it applies well beyond this one phenomenon. Every measuring instrument sits inside something. A telescope on a mountain sits inside an atmosphere that glows. A telescope on a spacecraft sits inside a vehicle that outgasses, radiates heat, sheds paint, and, as it turned out, manufactures its own light out of the material it is flying through. There is no neutral vantage point from which to observe the universe. There is only a series of platforms, each with its own contamination, and the work consists largely of characterizing your own platform well enough to subtract it. The shuttle glow was an unusually literal version of that problem. The contamination was visible to the naked eye, sitting 10 centimeters from the instrument, and it still took most of a decade to identify. A considerable amount of effort went into characterizing it. Spacelab 1 carried a spectroscopic assessment of the shuttle's optical environment. STS-41G in October 1984 obtained high-resolution measurements of both the quiescent glow and a version deliberately induced by firing the vernier thrusters, and found the background glow considerably fainter than earlier flights at similar altitude. STS-39 flew an infrared background survey on a free-flying platform released from the payload bay, which allowed the glow to be studied from outside the vehicle producing it. An airglow experiment built at the University of Arizona flew on several missions, including STS-69 in September 1995. Laboratory work reproduced the mechanism on the ground in 1990. An early competing hypothesis, published in 1984, attributed the glow to beam plasma discharge and critical ionization. It was largely superseded by the nitrogen dioxide model, though it was never trivially disproved, and it is more accurate to describe it as an alternative that lost than as a mistake. The STS-39 free flyer deserves a moment of its own, because the arrangement was clever. The problem with studying a glow attached to your own vehicle is that you are inside the vehicle. Every measurement is made from within the thing being measured, at a fixed short distance, with no way to see it in profile. Releasing an instrumented platform from the payload bay solved that. The shuttle flew alongside its own detached observer, which could watch the orbiter from outside, at a distance, against the black of space, and record how the glow was distributed across the vehicle's surfaces as the orientation changed. It is one of the few cases in which a crewed spacecraft has been able to look at itself. One honest limitation belongs at the close of this entry. Whether the International Space Station exhibits the same RAM glow is not something that can be stated confidently in either direction. The physics predicts a much weaker effect at the station's roughly 400-kilometer orbit, because atomic oxygen density there is far lower than at 240. Atomic oxygen erosion of station materials is thoroughly documented through years of materials exposure experiments mounted on the exterior, the same chemistry acting destructively rather than luminously, quietly eating polymers over the course of years. But there is a persistent confusion that should be cleared up directly. The beautiful photographs of a green glowing band above the Earth's limb, which circulate constantly labeled as station glow, are not this phenomenon. They are atmospheric airglow, the subject of the previous entry, produced 90 kilometers below the station by an entirely different mechanism. The two are conflated routinely, including in captions that ought to know better. The glow described in this entry was made by the atmosphere the vehicle was flying through, striking the vehicle itself. The atmosphere had another trick, considerably larger, that took the better part of a century to be believed at all. Number 9. The lightning that goes the wrong way. On the night of the 6th of July 1989, a University of Minnesota team was working at a field site about 60 kilometers northeast of Minneapolis. They were cross-calibrating optical sensors ahead of a sounding rocket flight, which is routine, unglamorous preparation work. Robert Franz was testing a low-light television camera at 60 frames per second, recording stars and a distant storm system when a cable connector failed. He stopped, found the fault, and replaced it. Moments after he restored the connection, the monitor showed a twin flash of light above the horizon. 2 video frames had captured a pair of luminous columns towering above thunderheads roughly 250 kilometers to the north. The result was published the following year under a title of Admirable Flatness, television image of a large upward electrical discharge above a thunderstorm system. A phenomenon that pilots had been reporting for decades and that had been dismissed for just as long, had been accidentally filmed by a man fixing a cable. The dismissal has a longer history than the discovery. The physicist C.T.R. Wilson, who won a Nobel Prize for inventing the cloud chamber, predicted on theoretical grounds in the mid-1920s that electrical breakdown should occur high above thunderstorms. He may have witnessed one himself in 1956. Through the following decades, airline and military pilots flying above and beside storm systems reported upward discharges rising out of the tops of clouds. Those reports were not investigated. They were discounted as folklore, as fatigue, as misidentification of ordinary lightning seen from an unusual angle. Pilots who reported them learned, in the way that professionals learn these things, not to bother. The reports were only collected and published formally in 1989, the same year as the accidental video. For most of the 20th century, a large population of trained observers with an excellent view of the phenomenon were telling the truth about something real, and were quietly filed as unreliable. It is worth being fair to the people doing the dismissing, because they were not being lazy. The reports were genuinely difficult to credit. They described lightning traveling upward, out of the top of a storm, into air far too thin to support the kind of electrical breakdown that produces ordinary lightning. They came from observers in motion, at night, at altitude, looking at a phenomenon lasting a few hundredths of a second, with no photographs and no instruments. They were inconsistent with each other in the details, and they arrived without any theoretical framework that would predict such a thing, except for Wilson's, which was 50 years old, largely forgotten, and had never been taken up. That is a recognizable pattern, and it is one of the reasons this entry sits where it does on this list. An observation that is fleeting, unphotographed, made by a moving observer and unsupported by any expected mechanism will not be believed, no matter how competent the observer or how many of them there are. What broke the pattern was not a better argument. It was 2 frames of videotape. When the phenomenon finally needed a name, Davis Sentman of the University of Alaska Fairbanks called them sprites, after the air spirits in Shakespeare, Ariel and Puck. The choice was deliberate and slightly defensive. He wanted a name that implied no physics whatsoever, because nobody yet knew what the physics was, and any descriptive name would have committed the field to a mechanism prematurely. The family turned out to be larger and considerably stranger than anyone expected, and each member behaves differently. Sprites span roughly 50 to 90 kilometers in altitude. They are red-orange, from excited molecular nitrogen, with blue tendrils hanging below. The larger ones, called jellyfish sprites, which describes them well, reach 50 kilometers across. High-speed imaging at 10,000 frames per second revealed that a sprite is not a bolt at all. It is a cluster of ionization balls, each 10 to 100 meters wide, launched at around 80 kilometers and traveling downward at up to 10% of the speed of light, followed milliseconds later by more balls moving upward. They can appear as much as 50 kilometers horizontally displaced from the lightning stroke that triggered them, which is part of why they were so hard to associate with anything. Blue jets leave cloud tops at 100 to 140 kilometers per second, fan outward into cones reaching about 50 kilometers, and last 200 to 300 milliseconds, long enough, just, for a human eye to register as motion rather than as a flash. The first one ever recorded was captured on monochrome space shuttle video over Australia on the 21st of October 1989, 3 months after the Minnesota video. Gigantic jets are the largest members of the family. They terminate at about 90 kilometers and physically connect a cloud top to the ionosphere, a conducting bridge between the weather and the edge of space. One observed from Arecibo Observatory on the 14th of September 2001 rose initially at 50 kilometers per second, accelerated through 160, then 270, then split and reached at least 2,000 kilometers per second. In under a second, it went from roughly the speed at which a spacecraft leaves Earth orbit to something crossing the distance from London to Cairo every 2 seconds. There are smaller members too, and the naming convention held. Blue starters are the runts of the family, discharges that leave the cloud top and give up almost immediately, topping out near 20 kilometers. And a sprite halo is a separate structure that can precede the sprite itself by about 1 millisecond, a flattened pancake of light roughly 50 kilometers across and 10 kilometers thick, centered near 70 kilometers altitude. It appears, the sprite descends through it, and both are gone before a human eye could register that anything happened. Gigantic jets remain the rarest and least understood. On the 22nd of July 2002, 5 of them, each 60 to 70 kilometers long, were recorded over the South China Sea from an observing station in Taiwan. 5 events, in one storm system, in one night, which is more than most researchers see in a career of looking. And then there are elves, which are the strangest of all. An elve is a dim expanding ring about 400 kilometers in diameter, lasting roughly 1 millisecond, at about 100 kilometers altitude. Sit with those numbers for a moment. A ring of light 400 kilometers across, wide enough to cover England from coast to coast, that exists for 1,000th of a second. It is produced when the electromagnetic pulse from a lightning stroke races outward and upward at the speed of light, striking the base of the ionosphere and exciting it in an expanding circle. Nobody could have seen one with the naked eye. The first was found in Shuttle video, shot off French Guiana on the 7th of October 1990. Observing these from orbit changed what could be measured, because from above, a storm's cloud deck stops being an obstruction and becomes a stage floor. Here is what that looks like from inside the cupola. The station is crossing India, moving east, and the Bay of Bengal is coming up ahead in darkness. Below and in front, there is a storm system spread out across several hundred kilometers of ocean, and from 400 kilometers up, it does not look like weather. It looks like a field of lit cloud, flat, textured, illuminated from within by lightning happening underneath it. each stroke turning a patch of cloud into a soft, glowing lantern for a fraction of a second, dozens of them at any moment, scattered across the whole system like a city seen through fog. There is no sound, and there is no sense of scale, and the whole thing is drifting past at 8 kilometers a second. A camera is braced against the glass, because there is no other way to hold it steady. And then, out of the top of that cloud deck, something comes up. Not down. Up, a thin blue thread rising away from the cloud, toward the camera, lasting a fraction of a second, and then another, and then another. They are coming out of the top of the storm and climbing towards space, and the only reason anybody knows how many there were is that the shutter was already open. That is not a reconstruction. In September 2015, ESA astronaut Andreas Mogensen positioned himself in the cupola and filmed a thunderstorm over the Bay of Bengal as the station crossed India. In 160 seconds of video shot on a handheld camera, he captured 245 blue discharges in the cloud-top layer near 18 kilometers, including a pulsating blue jet reaching about 40 kilometers. It was not luck. It was a targeted experiment, planned in advance with Danish atmospheric physicists, aimed at a specific storm system on a specific pass. And it worked. 3 years later, the station received a permanent instrument for the job. The Atmosphere Space Interactions Monitor launched on the 2nd of April 2018 and was installed on the exterior of the European Columbus module 11 days later. It carries 2 systems, a multispectral imaging array of cameras and photometers working in the optical and ultraviolet, and an X-ray and gamma-ray sensor. Its headline result was published in January 2021 and became the first front-page result in a major scientific journal from a European station experiment. Above a cloud top near Nauru in the Pacific, the instrument recorded 5 intense blue flashes, each lasting about 10 microseconds. One of them launched a blue jet up into the stratosphere and also generated an ELV reaching up to about 100 kilometers. 5 flashes, 10 microseconds each, at the top of a cloud in the middle of the Pacific, and the resolution to catch them existed only because an instrument had been bolted to the outside of a space station specifically to look for them. The most extreme member of the family is not visible at all, and it was found the same way as the first sprite, by accident, by an instrument looking for something else. Terrestrial gamma-ray flashes were discovered in 1994 by a detector aboard the Compton Gamma Ray Observatory, which had been built to study gamma-ray bursts from distant galaxies. Instead, it kept catching sub-millisecond bursts coming from below, originating above thunderstorms at roughly 10 to 15 kilometers altitude. The energies are difficult to accept. Photon energies run from 10 to 20 million electron volts, with a verified tail reaching about 100 million. For comparison, a photon in a medical chest X-ray carries roughly 300ths to 1500ths of a million electron volts. 100 million electron volt photon from a thundercloud is on the order of 1,000 times more energetic than the radiation used to image a human rib cage. These are the highest energy natural photon emissions known anywhere on Earth. They are produced by weather. A thunderstorm over the Pacific is, for a fraction of a millisecond, a particle accelerator. Work with the station instrument has been steadily tightening the connection between these phenomena. A paper in 2019 was the first to indicate that lightning triggers both the gamma-ray flashes and the ELVs, establishing that what had been catalogued as 3 or 4 separate curiosities are stages of a single process. A paper in 2024 imaged 3 bright gamma-ray flashes, together with the storms that produced them, which is the observational equivalent of finally photographing the suspect at the scene. The emerging picture is that an ordinary thunderstorm is doing considerably more than anyone assumed. Below the cloud base, it is doing what everyone has always seen it do. Above the cloud top, it is launching discharges into the mesosphere, ringing the ionosphere like a struck bell, and occasionally accelerating electrons to energies that would be respectable in a laboratory accelerator. All of it invisible from directly underneath, all of it lasting between 1,000th and 1/10th of a second, and none of it suspected until someone happened to be looking sideways with the right camera. What remains genuinely unknown is considerable, and NASA states it plainly. After more than 30 years, the root cause of sprites remains unknown beyond a general association with positive cloud-to-ground lightning. Not all storms produce them, and nobody can say reliably in advance which ones will. Sprites were observed during Hurricane Matthew in 2016, but their role in tropical cyclones is not understood. Whether any of these events meaningfully affect atmospheric chemistry, greenhouse gases, ozone, is an open question that the European Space Agency explicitly flags as speculative. There is one story attached to this subject that should be handled carefully, because it is repeated often and the sourcing does not hold. In 1989, a NASA stratospheric balloon payload was lost at 120,000 feet over Texas, and the loss is routinely attributed to a sprite strike. The attribution was made retroactively, years later, necessarily so, since the word sprite did not exist until late 1993. Sources also disagree on the launch date. It may well have been a sprite. It is not documented that it was. One point of accuracy is worth preserving against a common overstatement. Sprites do not reach space. 90 kilometers is still below the 100-kilometer line conventionally used to mark the boundary, and describing them as lightning that reaches space is wrong by a margin that matters. That phenomenon went unbelieved for a century because nobody expected it to exist. The next one went unnoticed for years because nobody had any reason to open the panel. Number 8. The thing that grew on Mir. The Mir base block launched on the 20th of February 1986. The first crew launched on the 13th of March and docked 2 days later. The station operated for 15 years and was deliberately deorbited on the 23rd of March 2001. For most of those 15 years, something else was living aboard it. The numbers are documented, and they are larger than most people expect. Across Mir's operational life, 234 species of microorganism were isolated from the station, 108 species of bacteria, and 126 species of fungi. Airborne fungal concentrations in the cabin fluctuated between 20,000 and 50,000 colony-forming units per cubic meter of air, with Penicillium and Aspergillus the dominant genera. Cladosporium and Fusarium were also identified. For comparison, a well-ventilated indoor space on Earth typically runs in the hundreds of colony-forming units per cubic meter. Mir was running 1 to 2 orders of magnitude above that, in a sealed volume, with air that had nowhere else to go. Where it grew is the part that made engineers uncomfortable, and the list reads less like a hygiene problem than like a slow structural one. Documented colonization sites aboard Mir include components of the air conditioning system, cable insulation, which was being used directly as a food source, the oxygen electrolysis block, the equipment that made the crew's breathable air, where reports describe zones completely covered with mold growth and destruction of the plates, the headphone of a spacesuit, the lavatory pan, thermal control system piping, the urine processing assembly. On the earlier Salyut 6 station, biofilms had already been found on piping and equipment behind the wall panels, which means this was not a mere specific failure. It was a property of long-duration crewed spacecraft that had simply not been anticipated when those spacecraft were designed. The Windows story requires care, because the popular version and the documented version are not the same thing, and the difference matters. The defensible account, which appears in peer-reviewed literature, is this: fungal biofilms of the species Penicillium chrysogenum began growing on the rubber seals around Mir's windows, and expanded from those seals onto the quartz pane and the titanium frame, damaging both. That is a real finding about a real organism doing real damage to a real spacecraft. It is also considerably less dramatic than what usually gets told. The version in wide circulation holds that cosmonauts in 1988 saw something growing on the outside of a window, that it formed a mat thick enough to obscure the view, that it was eating its way through the titanium and quartz, and that it was trying to get inside. None of that holds up. The scientist who led the Russian research stated explicitly that the metal, the glass, and the plastic were not the microbe's food source. The organisms were eating human detritus, shed skin cells, condensate, organic residue, the ordinary material that accumulates wherever people live. What they excreted were corrosive metabolites, including organic acids such as acetic acid, and those acids slowly pitted titanium, plastic, and glass over a period of years. It is chemical etching over a long time as a byproduct. It is not consumption, and it is not directed, and nothing was trying to get anywhere. The organisms were also entirely ordinary terrestrial molds, the same genera found in damp buildings everywhere on Earth, carried up by crews and cargo. Nothing about them was novel, mutant, or extraterrestrial, and no serious source has ever claimed otherwise. There is one more finding from the Russian work that deserves stating, because it is the least reassuring sentence in this entry. The conclusion was that the microbial community adapts to spaceflight conditions over time, that it does not merely persist unchanged in an unfamiliar environment, but adjusts to it. 15 years is a long time for organisms with generation times measured in hours. What was aboard Mir at the end was not simply what had been carried up at the beginning. The most concrete anecdote from Mir is not about mold at all. It is about water. Crew opened a rarely accessed service panel in the Kvant 2 module and found a free-floating mass of condensate that had accumulated behind it, in a space nobody had needed to look into for a long time. NASA astronaut David Wolf, who was aboard Mir from September 1997 to January 1998, described globs the size of a bowling ball or a beach ball. He described them as gooey, slimy and ice-cold, clouded with dozens of species of bacteria and fungi, and beginning to track down the structure into the wiring. Samples returned to Earth were reported to contain bacteria, protozoa, dust mites, and spirochetes. 2 honest qualifications belong on that account. The size is an eyewitness estimate given in interviews rather than a measurement, and a basketball-sized volume is roughly 7 liters of water. And sources give the year as either 1997 or 1998. The physical explanation is the same one from the first entry on this list, arriving with an unpleasant consequence. Without gravity, there is no drainage. Condensation that would run down a wall on Earth and evaporate, or pool somewhere it could be seen and mopped, instead collects wherever surface tension holds it, which is behind panels, in corners, against cable runs, out of sight. The station's humidity control removed water from the air in the occupied volume. It could do nothing about water that had already migrated somewhere nobody was looking. And a warm, dark, permanently damp cavity behind a wall panel, supplied continuously with organic material shed by human beings, is an excellent place to grow things. It is, in effect, the same environment that produces mold behind a bathroom tile, except that nobody could see it, and there was no way to open a window. On the current station, the work has become far more systematic, and the most recent findings are not what most people would guess. The most comprehensive survey to date was published in February 2025. It is based on 803 paired environmental surface samples collected during Expedition 64 across 9 modules of the American segment, each analyzed by 3 separate methods: genetic sequencing of what was present, deeper sequencing of what those organisms could do, and chemical analysis of the compounds they left behind. The result is a three-dimensional map of the microbes and chemistry of an entire spacecraft. 3 findings came out of it. The first is that how each module is used strongly drives its microbiology and chemistry. The station is not one environment. It is 9 environments, and the microbial community in the module where people exercise is not the community in the module where experiments run or the one where people eat. The second is that the microbial communities aboard are less diverse than in most built environments on Earth. Not more, less. The third follows from the second, and it is the one that reverses the assumption underneath this entire entry. The station sits at the extreme end of what the authors describe as an axis of industrialization, in the company of hospitals and submarines. These are the most thoroughly cleaned interior spaces our species produces, and what they share is not health. It is sterility. The recommendation that emerged is genuinely counterintuitive. The station may be too clean. The authors suggest that crews on long missions might benefit from the deliberate introduction of beneficial environmental microbes, in the way that gardening in healthy soil exposes people on Earth to a microbial diversity their immune systems evolved to expect and now frequently do not get. After 40 years of trying to keep spacecraft clean, the most thorough survey ever conducted of one concluded that the problem might be the opposite of the one everybody had assumed. The station has also produced new species, which is a genuinely odd thing for a sealed metal box to do. Methylobacterium ajmalii was described in March 2021 from 3 strains isolated aboard in 2015 and 2016. 5 further novel bacterial species from the station were reported in 2023. It should be said clearly what this does and does not mean. These organisms were not created in orbit. They are terrestrial bacteria that had simply never been formally described before, found aboard the station because the station is one of the most thoroughly sampled interior spaces in existence. The same effort applied to any office building would also turn up species new to science. Microbiology has described a small fraction of what exists, and the station gets sampled far more carefully than a kitchen. A related organism is frequently and wrongly attributed to the station in popular coverage, and the correction is worth making. Nyalia tiangonggensis was isolated aboard China's Tiangong station in May 2023 and formally described in 2025. It is a spore-forming bacterium with a heightened response to oxidative stress, unusual biofilm-forming ability, and the capacity to break down gelatin as a source of nitrogen and carbon. It is a genuinely interesting organism. It is not from the International Space Station, and headlines that place it there are simply wrong. That does not cancel the mere findings. Both things are true at once, and they pull in different directions, which is what makes this a genuinely hard design problem rather than a simple one. Fungi degrading cable insulation and electrolysis plates is a hardware reliability issue with no upside. Biofilms are substantially more resistant to antibiotics than free-floating cells of the same species, which compounds the medical risk. And spaceflight is independently associated with immune dysregulation in crew members, meaning the people aboard are somewhat less equipped to handle an infection than they would be at home. So the goal cannot be sterility, and it cannot be indifference either. It is something more difficult, controlling the organisms that eat spacecraft while preserving the ones that keep people well, in a sealed volume, for years, with no resupply of either. The practical measures being planned reflect that. Biodeterioration-resistant materials. Condensate control behind panels, so that the water never accumulates in the first place. Routine molecular monitoring rather than culture-based sampling, since most of what grows aboard will not grow in a petri dish. And, possibly, engineering diversity in rather than only out. There is a coda worth adding, because it is a genuine gap in the record. Mir was deliberately deorbited over the South Pacific in March 2001 and broke up on re-entry. There was no microbiological sampling of the debris and no study of whether anything aboard survived the descent. Any claim that Mir's microbes made it into the ocean is unsupported speculation. What is true is simpler and quieter. 15 years of accumulated life aboard the longest inhabited object humans had ever built was destroyed, unstudied, in a single afternoon. It is worth sitting with what that station represented as a habitat rather than as a machine. For 15 years it held a small, warm, humid volume of air at a comfortable temperature, continuously supplied with organic material, never rained on, never frozen, never disturbed by weather, and never once opened to the outside. There is almost nothing like it on Earth. Every enclosed space we build eventually gets aired out, cleaned down to the substrate, or abandoned. Mir was sealed, occupied, and maintained at conditions ideal for growth for a decade and a half, without interruption, and the things that grow in such conditions did what they have always done. Life inside the station is one thing. The light outside it is another, and at 400 kilometers, the station is not always looking at that light from a safe distance. Number 7. The Aurora seen from inside it. From the ground, Aurora hangs above you. You look up at curtains suspended somewhere in the sky, and because you are seeing them nearly end-on from a great distance, they read as a flat display painted on the dome of the night. Beautiful, but essentially two-dimensional, with no clear sense of how far away they are or how large. Almost everyone who has watched an aurora has watched it that way, and almost everyone has come away without any accurate idea of its scale. From the International Space Station, orbiting at roughly 400 to 420 kilometers, you look down and sideways at the same phenomenon, and it becomes something entirely different. Crews describe rivers of green light lying on top of the planet, with the curtains visible edge-on as vertical rays rising off the limb. The three-dimensional structure that is impossible to perceive from below becomes immediately obvious. These are not sheets hanging in the sky. They are enormous walls of light standing on the atmosphere, hundreds of kilometers tall, and from orbit you can see how tall they are because you are level with them. The altitudes explain why the view inverts so completely. Green comes from atomic oxygen at 557.7 nanometers, the same emission line responsible for airglow, produced by the same atom at a different excitation, emitted at roughly 100 to 150 kilometers. Red comes from atomic oxygen at 630 nanometers, from roughly 200 to 300 kilometers, with some sources extending it as high as 400 to 500. Blue and purple come from molecular and ionized nitrogen and produce the purplish lower border, generally beneath the green. The reason for that layering is elegant, and it is the same mechanism that constrains airglow to a narrow band. The excited oxygen state responsible for the red line has a long radiative lifetime. The atom takes a comparatively long time to release its photon, long enough that at low altitude, collisions with other molecules will knock the energy out of it before it ever gets the chance to glow. So red light only survives where the air is thin enough for an excited atom to be left alone long enough to radiate. Which means the color of an aurora is a direct readout of atmospheric density. Green where the air is thicker, red where it is thin, purple at the bottom edge where nitrogen dominates. An aurora is a diagram of the atmosphere drawn in light, and from the ground you cannot read it, because you cannot tell which part is nearer. There is a diagnostic use for this that turns the display into an instrument. The nitrogen band at 427.8 nanometers is the standard measurement used to estimate the energy of the electrons arriving from space. Higher energy electrons penetrate deeper into the atmosphere before they are stopped, and they excite different species at different depths. Measuring the ratio of emissions, therefore, tells you how energetic the incoming particles were, which means the colors of an aurora encode not only the density of the air, but the character of the storm that produced them. What looks like a light show is a readout from a detector several hundred kilometers tall. It should be said that published altitude ranges vary between sources, sometimes considerably. The ordering is robust: blue lowest, green in the middle, red highest, but the exact boundaries are not, and anyone quoting precise figures is quoting one paper's numbers rather than a settled consensus. And it means the station, at 400 kilometers, sits above the green layer entirely and inside the altitude range where the red emission is produced. That is documented rather than folklore. NASA published an image feature in September 2014 titled "Flying Through an Aurora," built around a photograph taken from the station by ESA astronaut Alexander Gerst and posted by him in August that year. His caption is one of the more affecting things any astronaut has written. "Words can't describe how it feels flying through an aurora," he wrote. "I wouldn't even know where to begin." The other crew accounts are consistent in their inarticulacy, and that consistency is itself worth noting. These are people selected in part for their ability to describe technical situations precisely under pressure, and on this subject, they reliably run out of language. Reed Wiseman, photographing Aurora from the station in 2014, "Never in my wildest dreams did I imagine this." Scott Kelly, during his year-long mission, "Yesterday, we had some incredible auroras outside, like none I've ever seen before, with regards to how vivid it was." Don Pettit, posting Aurora video in January 2025, described it simply as "flying over Aurora, intensely green," and elsewhere as a green vaporous turbulence lying below the station. One clarification belongs here, because the phrase "flying through an aurora" invites an overstatement. The station is well above the 100 to 150 kilometer green layer and does not fly through it. What it can genuinely be immersed in is the high-altitude red emission. Gerst's line is a real astronaut quote about a real experience. It is not a physics claim, and it should not be turned into one. Don Pettit deserves particular attention in this entry because he is the most technically inventive photographer who has ever worked in orbit, and because he solved the Aurora problem himself, with equipment that was not designed for it. The difficulty is straightforward. Aurora is faint, which means it needs a long exposure. But modern digital sensors accumulate electronic noise, and beyond about 30 seconds, that noise begins to overwhelm the signal. You get a brighter image that is also a worse one. Meanwhile, the station is moving at nearly 8 kilometers a second, so anything longer than a few seconds smears the ground into streaks anyway. His solution was to shoot many consecutive 30-second frames and stack them in software afterwards, synthesizing exposures of 10 to 15 minutes and longer, while keeping each individual frame short enough to stay clean. The technique is now common among astrophotographers. He was doing it in orbit, by hand, on a station. He went further than that. During Expedition 30, he modified a handheld camera for near-infrared sensitivity, specifically to record the red auroral emissions that ordinary cameras render badly. On a later flight, he captured a 30-minute stacked exposure, spanning an entire orbital night, sunset to sunrise, with a fast, wide-angle lens. He was also, on his final mission, the oldest active NASA astronaut. He launched aboard Soyuz MS-26 on the 11th of September 2024 and landed on the 20th of April 2025 on his 70th birthday after 220 days in orbit. He had first flown to the station in 2002. The aurora is not always benign for the people watching it, and this is where the entry turns. During the Halloween solar storms of 2003, a series of flares and coronal mass ejections peaking on the 28th and 29th of October, which produced 17 major X-class flares, the station crew was ordered into the Zvezda service module to shelter from elevated radiation. They were not admiring the display. They were sitting in the most heavily shielded part of the station, waiting for it to pass. One of those flares, on the 4th of November, initially registered as X-28 before saturating the monitoring satellite's detectors entirely, and has since been modeled as possibly as strong as X-45. It is the largest flare ever recorded by those instruments, and the recording stops short of the actual value because the instruments ran out of scale. On the ground, aircraft were rerouted away from polar routes. A 1-hour power outage occurred in Sweden. This is the part of the Aurora that ground observers almost never encounter. Standing in a field in Norway looking up, there is no sense at all that the display overhead is a symptom of anything, or that it has consequences beyond the visual. From the station, it is not possible to maintain that separation, because the same event that produces the light also produces the radiation the crew has to shelter from. The light and the hazard arrive together, from the same source, at the same moment. The aurora is what the hazard looks like when it hits the air. The historical extremes put that in proportion. The Carrington event of the 1st and 2nd of September 1859 began with a white light solar flare observed independently and simultaneously by Richard Carrington and Richard Hodgson, the first recorded observation of a solar flare in history, lasting about 5 minutes. The associated ejection crossed to Earth in under 18 hours, which remains the fastest transit ever recorded. Telegraph systems sparked. Some stations caught fire. Operators reported being able to send messages with the batteries disconnected, running on current the sky was supplying. Aurorae was seen well into the tropics. The intensity of that event is genuinely disputed. Analyses of a magnetic record from Bombay support a disturbance figure of about -1600 nanotesla. Another proposes -1760, and other reconstructions come out substantially smaller. It should be described as a range rather than a number. And then there is the event that demonstrated what this actually means for a modern society. On the 13th of March 1989, at 44 minutes past 2 in the morning Eastern Time, geomagnetically induced currents tripped a capacitor at the James Bay Hydroelectric Complex in Quebec. The entire Hydro-Quebec grid collapsed in 90 seconds. 6 million people lost power for 9 hours, with outside temperatures near -15 degrees Celsius. Researchers at Natural Resources Canada describe it as the biggest geomagnetic storm of the space age. Between the 7th and 11th of May 2024, an active region produced 8 X-class flares and at least 7 coronal mass ejections, and the resulting storm reached the highest storm category for the first time since 2003. That 2024 storm carries a name, and the reason is worth knowing. It is called the Gannon storm, after Jennifer Gannon, a space weather researcher who died a week before it occurred. Naming the largest geomagnetic storm in 2 decades after someone who spent her career studying exactly that phenomenon, and who missed it by 7 days, is the kind of gesture a scientific community occasionally gets right. The thing worth holding on to is this. The same light that 6 million people in Quebec were looking at in March of 1989, the aurora that had come far enough south to be visible over southern Canada and much of the northern United States, and that a great many of them went outside to admire, was at that exact moment taking their heating away in the middle of a Canadian winter night. That light was harmless to look at, whatever else it was doing. The next entry is about a photograph that was equally harmless and that has been offered as evidence of something else for the better part of 30 years. Number 6. The blanket that became a satellite. Space Shuttle Endeavour launched on the 4th of December 1998 on mission STS-88. It was the first American assembly flight for the International Space Station, and its job was to mate the American node Unity to the Russian module Zarya, the first two pieces of a structure that has now been continuously inhabited for more than a quarter of a century. The crew was Robert Cabana, Frederick Sturkow, Nancy Curry, Jerry Ross, James Newman, and Sergei Krikalev. Ross and Newman conducted 3 spacewalks on the 7th, 9th, and 12th of December. The first ran 7 hours and 21 minutes and completed 40 electrical connections between the 2 modules, by hand, in vacuum. During that work, a trunnion pin thermal cover came loose. A trunnion pin is a fitting used to hold payloads in the shuttle's cargo bay, and the covers are small insulating blankets that protect them. Commander Cabana's radio call about it is on the record and is entirely unremarkable in tone. "Jerry, one of the thermal covers got away from you." It was never recovered. The paper trail on that object is complete and has been public the whole time. United States Space Command catalogued it as Object 25570, International Designator 1998-067C, classified as Spacewalk Debris Trunnion Pin Cover. Launched the 4th of December, 1998. Re-entered the 14th of December, 1998. It existed as a tracked object for approximately 10 days. On the 11th of December, Sergei Krikalev photographed something drifting near the orbiter. 2 frames were catalogued by NASA's Johnson Space Center under the plainest description available: space debris. Those 2 photographs became, over the following 2 decades, the visual anchor of one of the most durable myths in modern spaceflight, the claim that they show a 13,000-year-old alien satellite in polar orbit, known as the Black Knight. James Oberg analyzed the frames. He is a space journalist and a former NASA engineer who had worked on the STS-88 trajectory design team and who was personally acquainted with both Ross and Krikalev. His conclusion was that the object is a nearby thermal blanket and that its apparent size and its lighting are entirely consistent with a small object close to the orbiter rather than a large object far away. There is a further problem with the myth that is rarely stated and that settles the matter on geometry alone before any photographic analysis is needed. The legend insists that the object sits in a near-polar orbit. The shuttle and the station fly at 51.6 degrees of inclination. Those 2 orbital planes cross at a steep angle, which means an object in a polar orbit and an object in the shuttle's orbit encounter each other at enormous relative velocity. They pass each other in seconds, like 2 cars crossing an intersection at speed. An object in polar orbit could not possibly be photographed drifting slowly alongside Endeavour in the way these images show. The relative motion is wrong by orders of magnitude. Whatever is in those frames was moving at very nearly the shuttle's own velocity, which means it was in very nearly the shuttle's own orbit, which means it came off the shuttle. What makes this entry genuinely interesting is not the debunk, which takes about a paragraph. It is the archaeology of how the legend was assembled, because almost every component of it is a real event that has been detached from its context and glued to the others. None of the original stories used the name Black Knight. Not one. In 1899, Nikola Tesla, working at Colorado Springs, reported receiving regular repeating radio signals that he speculated might be Martian in origin. The signals were real. Tesla was an extraordinarily capable experimentalist, and there is no reason to doubt he received something. The most plausible modern explanation is pulsars, rotating neutron stars that emit with clock-like regularity, which were not identified until 1968, 69 years later. Tesla never described a satellite. He described a signal. In 1928, a Norwegian amateur radio operator named Jørgen Hals in Oslo heard his own transmissions returned to him after delays of several seconds. The phenomenon is called long-delayed echoes. It is entirely real. It was investigated by serious scientists at the time, and it is still not fully explained. it remains a genuinely open problem in ionospheric physics. Nothing extraterrestrial was claimed by anyone involved. In 1954, the UFO author Donald Keyhoe, a retired Marine major who was promoting a book, told newspapers that the United States Air Force had detected 2 satellites orbiting Earth. This was at a time when no nation on the planet could put anything into orbit. The coverage reads as tongue-in-cheek and was not intended seriously by the papers that ran it. The British Black Knight rocket program ran from 1958 to 1965, testing re-entry vehicles, and a Black Knight satellite launcher was announced in 1964. It never orbited anything at all. It contributed nothing whatsoever to the legend except a name, entirely by coincidence, which is the sort of accident that makes myths sound older and more coherent than they are. In February 1960, a magazine reported that the United States Navy had detected a dark object suspected of being a Soviet spy satellite. This one was resolved almost immediately. A follow-up piece the following month identified it definitively as the remains of an American Air Force satellite that had gone astray. The correction is as public as the original story and considerably less often cited. In 1963, Gordon Cooper is claimed to have reported a UFO on his 15th orbit aboard Mercury 9, supposedly confirmed by tracking stations on the ground. There is no evidence that this happened. Neither NASA's mission transcripts nor Cooper's own copies of them contain any such report. And in 1973, the Scottish author Duncan Lunan analyzed the 1928 radio echoes, plotted the delay intervals as though they encoded a star map, and speculated that they had come from a 13,000-year-old probe in lunar orbit originating near the star Epsilon Bootis. That is where the 13,000 years enters the story, and it deserves to be followed to its end. Lunan later publicly retracted the claim. He said he had made outright errors and that his methods had been unscientific. The number survived the retraction by 50 years, entirely detached from the man who produced it and from his own assessment of it. It is worth noticing what the assembly process actually consists of, because it is the same process every time. Take a real event with an unresolved element, Tesla's signals, Halsey's echoes. Take a real event whose resolution is less famous than the original claim, the 1960 dark satellite. Take a claim from someone with a book to sell. Take a coincidental name from an unrelated engineering program. Take a speculative interpretation that its own author withdrew. Take a photograph with no scale reference. Arrange them in chronological order, and the arrangement itself does the persuading, because a list of dates spanning a century looks like accumulating evidence rather than what it is. 7 unrelated things sorted by year. None of the individual components requires anything unusual to explain. The legend exists entirely in the sequence. The best summary of the whole construction belongs to Martina Redpath of Armagh Planetarium, and it is worth quoting in full. Black Knight is a jumble of completely unrelated stories, she wrote, reports of unusual science observations, authors promoting fringe ideas, classified spy satellites, and people over-interpreting photos. These ingredients have been chopped up, stirred together, and stewed on the internet to one rambling and inconsistent dollop of myth. One component of the myth deserves better treatment than the myth gives it, and that is the long-delayed echoes. Hals was a competent operator, and what he reported has been reproduced. Radio signals transmitted from the ground occasionally return to the transmitter after delays of seconds, sometimes many seconds, which is far too long to be explained by any straightforward reflection. A signal circling the entire Earth takes about 1/8 of a second. A signal reaching the moon and returning takes about 2.5. Delays of 10 or 15 seconds correspond to no obvious path at all. Proposed explanations have included signals becoming trapped in ducts within the ionosphere, reflections from plasma structures far out in the magnetosphere, and various mechanisms involving nonlinear interactions in the upper atmosphere. None has been established. It is a small, real, unresolved problem in radiophysics that has been quietly waiting for an answer since 1928. It deserves to be an interesting open question in its own right. Instead, it has spent 50 years as raw material for something else. There is a specific technical reason a photograph could carry this much weight, and it is the same reason that recurs whenever an object in space is photographed against nothing. An image of an object against the black of space contains no information about its distance or its size. None. A small object nearby and a large object far away produce identical images, and there is no way to distinguish them from a single frame, unless something else in the picture provides a scale reference, a known object at a known distance, a star field with measurable parallax, a second image taken from a different position. The Krikalev frames contain a lit object against black. That is all. Every claim about what it is depends entirely on an assumption about how far away it was, and the myth simply assumes the answer that makes the object impressive. The orbital mechanics settle it anyway. The object was moving with the shuttle. 10 days later, it burned up. There is something worth saying about the people in this story, since they tend to disappear behind the object. Sergei Krikalev, who took the two photographs, went on to become one of the most experienced spacefarers in history, having already been aboard Mir when the Soviet Union that sent him there ceased to exist. Jerry Ross, whose thermal cover it was, eventually flew 7 shuttle missions, tying the record for the most spaceflights by any individual. Robert Cabana, who made the radio call, later ran Kennedy Space Center, and the mission they were flying was the one that started it all, the flight on which the American and Russian segments of the station were first bolted together, in the first year after both countries had agreed to build the thing jointly. That is the context in which the photographs were taken. 2 former adversaries assembling a laboratory in orbit, one of them losing a piece of insulation in the process, and the other photographing it as it drifted away. What is left, when the legend is set aside, is a modest and rather appealing piece of history. A 10-day-old piece of insulation, lost by a spacewalking astronaut during the first assembly flight of the largest structure ever built in orbit, photographed by a Russian cosmonaut who was in the process of helping to bolt the American and Russian segments together. That object has been offered as proof of a 13,000-year-old alien machine for roughly 900 times longer than it actually existed. That story survived because a photograph carries no scale. The next one has survived for a much better reason. Nobody has ever been able to explain it. Number 5. The knocking on Shenzhou 5. Shenzhou 5 lifted off on the 15th of October, 2003, carrying Yang Liwei, and made China the 3rd nation to launch a human being into orbit under its own power. He flew alone. The mission lasted about 21 hours and 14 orbits, and he stepped out of the re-entry module on the 16th of October. By one Chinese count, he was the 241st human being to go to space. He was born in June 1965 in Liaoning province, in the northeast of the country, and he now holds the rank of Major General. Somewhere during those 21 hours, alone in a capsule roughly the size of a small car, he heard something. He described it publicly in an interview with China Central Television, reported in late November 2016, 13 years after the flight. His description is the single best sentence anywhere in this list, and it is worth giving in full rather than in the smoothed-down version that usually circulates. A non-causal situation I have met in space is a knock that appeared from time to time, he said. And then, it neither came from outside nor inside the spaceship, but sounded like someone is knocking the body of the spaceship, just as knocking an iron bucket with a wooden hammer. It neither came from outside nor inside. That phrase is doing an enormous amount of work, and it is the part almost every retelling drops in favor of the iron bucket, which is more quotable. But the iron bucket only describes the timbre. The first clause describes the experience, and the experience is the strange part. A sound that appears to originate in neither place is a sound with no locatable direction. Human hearing works by comparing the arrival time and intensity of a sound at two ears, and it is very good at this, good enough to place a sound within a few degrees. When that mechanism fails to produce an answer, the usual reason is that the sound is not arriving through the air at all. It is arriving through the structure, entering the body and the skull, directly from whatever a person is touching, which is a mode of hearing that carries no directional information whatsoever. That is a genuinely disorienting thing to experience under any circumstances. It is a different thing entirely when the structure in question is the only object between a person and vacuum. Here is what that was like. The capsule is small enough that he can touch most of it without unstrapping. It is quiet, not silent, because there are fans and pumps and the constant low noise of a machine keeping a person alive, but quiet in the way that a familiar machine becomes quiet once the ear has stopped listening to it. He has been in orbit for some hours. The Earth goes past the porthole and comes back. There is nobody else aboard, and there will not be for the rest of the flight. Then something knocks on the hull. Not a hum, not a creak, not a rush. A discrete percussive event with an attack and a decay, exactly the way a hammer sounds against a metal drum. It does not come from a direction. It is simply present, the way a sound is present when it arrives through the thing you are strapped to. He moves toward the porthole to look. Outside, there is the same nothing that has been there for hours. Nothing is attached to the spacecraft. Nothing is nearby. He goes back, and he waits. And then sometime later, it happens again. Yang has said he was very nervous. Nothing out of the ordinary appeared either inside or outside the spacecraft. The sound came intermittently, from time to time, in his words, rather than continuously, and that is worse in the specific way intermittent things are worse. A continuous noise becomes background within minutes. A noise that stops leaves a person waiting for it to start. After returning to Earth, he told technicians about it, and then did something admirable and completely futile. He tried to reproduce the sound on the ground with various instruments so that engineers could identify what had made it. He never managed it. He has said he never heard the exact sound again and never succeeded in recreating it. Both Chinese and international reporting are consistent on that point. The attempt at reproduction failed. And here is the detail that turns this from an anecdote into something more substantial. The same sound was reported by the crews of Shenzhou 6 and Shenzhou 7. Shenzhou 6 flew in October 2005 with Fei Junlong and Nie Haisheng on a 5-day mission. Shenzhou 7 flew in September 2008 with Zhai Zhigang, Liu Boming, and Jing Haipeng, and included China's first spacewalk. Different spacecraft, different crews, 5 years apart, same phenomenon. Which means it is not a misperception by one tired man on his first flight. Whatever it is a property of the vehicle or of the environment, and it recurs. Yang's response to that is the emotional center of this entry, and it is the response of a good commander rather than a good mystic. Before entering space, he said, "I have told them that the sound is a normal phenomenon, so there is no need to worry." He briefed his successors personally. He could not explain the thing that had frightened him, could not reproduce it, could not point to a cause, and what he did with that was make sure that no Chinese astronaut who came after him would have to feel what he had felt. He now categorizes it himself as a normal phenomenon, which is a slightly generous description of something nobody has identified, and which is exactly what you would want a commander to tell a rookie. It is worth pausing on the circumstances of that particular flight, because they are not the circumstances of an ordinary first mission. Yang was not simply the first Chinese astronaut. He was flying a vehicle design that no Chinese crew had flown, on a program that had been developed largely in isolation for a country that had staked considerable national prestige on the outcome. There was no crewmate to consult, and no established body of Chinese crew experience to compare notes against. When something knocked on the hull, there was nobody aboard who could say whether that was normal, because nobody in his country had ever been there to find out. Compare that with the situation on the International Space Station, where structural noise is thoroughly routine. Crews there hear the structure settle constantly. Pops, ticks, groans as modules pass in and out of sunlight, and nobody thinks anything of it, because every new arrival is briefed by people who have been living with it for months. The noise is identical in kind. The experience of it is completely different, and the difference is entirely a matter of whether someone has told you in advance, which is precisely what Yang did for the crews who came after him. The leading explanation is thermal stress on the hull, and it is physically sound even though it has never been formally confirmed. Two space engineering researchers at the National University of Singapore commented on the case when it became public. One made the general point that sound requires a medium, air particles, water molecules, or the atoms of a solid, and noted that if something were literally knocking, there could be something physically striking the spacecraft, while stressing this was purely speculative. His colleague offered what has since become the standard explanation. The noise was likely a result of expansion or contraction of the spaceship, especially since the temperature of the spaceship's exterior could change considerably within the orbit. The mechanism in plain terms is this. A spacecraft in low Earth orbit crosses the line between day and night roughly every 45 minutes. Its exterior swings from direct sunlight to Earth's shadow and back, with surface temperatures ranging from something like 120 degrees Celsius down to 100 below. Metal expands when heated and contracts when cooled. In a structure made of different materials joined together, those materials expand by different amounts, and stress builds at the joints. That stress does not always release gradually. Panels and fittings under differential load can hold, and then slip all at once, producing a pop, a crack, or a bang that is transmitted through the pressurized structure directly into the crew cabin. It is the same physics as a house creaking at night as it cools, or a car engine ticking in a driveway after a long drive. Scaled up to a metal capsule in vacuum and delivered to a man who has nowhere to go. Notice how well that explanation fits Yang's own description. A sound conducted through the structure itself would come from neither outside nor inside in any locatable sense, because it would be entering him through the seat and the hull rather than through the air. His most perceptually strange observation turns out to be the strongest evidence for the most mundane answer. There is a reason this entry sits at number 5 rather than lower down among the solved cases, and it is not that the explanation is implausible. It is that the explanation has never actually been demonstrated. Compare it with the Fireflies, 15 entries ago. Glenn reported something. Carpenter hit a wall and the particles appeared on demand, on cue, in the quantity predicted. The hypothesis made a specific testable claim. Someone tested it, and the test came back positive within 3 months. That is what a solved case looks like. Nothing equivalent has happened here. Nobody has instrumented a Shenzhou hull, recorded the acoustic event, correlated it against the thermal cycle, and published the correlation. What exists is a phenomenon reported by 3 crews, a plausible mechanism proposed by 2 academics in an interview, and a failed attempt at ground reproduction by the man who heard it. The mechanism is very probably right. It has not been shown to be right, and those are different things. What remains genuinely unexplained should be stated plainly, because this is the point on the list where the answers stop being clean. The exact mechanism has never been confirmed. The thermal stress explanation is the most physically plausible, and it is the one repeated across all of the coverage, but it is an expert hypothesis offered to journalists, not a published engineering finding from the Chinese space program. No technical report identifying the source appears to exist publicly. Yang's failure to reproduce it on the ground is odd if it were straightforward hull cycling, though it must be said that ground testing cannot replicate orbital thermal cycling in vacuum, so the failure may prove nothing at all. And there is no published account of whether the phenomenon persisted on later missions, from Shenzhou 9 onward, or aboard China's Tiangong stations. One more piece of sourcing needs correcting, because it circulates widely. A number of accounts state that Yang first revealed this in a memoir published in 2010. That could not be substantiated. The sourcing that holds up is the China Central Television interview from November 2016, carried by Chinese state media and international outlets within days of broadcast. If a date is going to be attached to when this became public, it should be that one. One framing deserves to be dismissed directly because it appears in nearly every headline about this story. Presenting it as a sound in a place where sound cannot travel is a category error. Vacuum outside a hull does not prevent structure-borne sound inside a pressurized cabin. There is air in the capsule. There is metal to carry the vibration. The physics is entirely ordinary. What is not ordinary is being alone inside it. That distinction is worth holding on to because it applies to a great many of the entries on this list. The physics is almost never exotic. Frost on a hull. Ice crystals in the upper atmosphere. Oxygen atoms recombining on a surface. Metal contracting as it cools. What makes these things extraordinary is not the mechanism but the circumstances of the observation. A single trained person, somewhere no human being has been, with no reference point, no colleague to consult, and no possibility of stepping outside to check. Young Li Wei heard his spacecraft get cold. That is very probably all that happened. He heard it while he was the only Chinese person who had ever been in orbit, 300 kilometers above the only place his species can breathe, in a vehicle nobody had flown, with no one to ask. Yang was alone when he heard it. The next entry involves 3 men who heard something together, behind the moon, with no way to ask anyone on Earth about it for another hour. Number 4. The music, on the far side of the moon. Apollo 10 launched on the 18th of May 1969 as the full dress rehearsal for the first lunar landing. It was the first mission to fly 2 crewed spacecraft to the moon and separate them in lunar orbit. Commander Thomas Stafford and lunar module pilot Eugene Cernan flew the lunar module, call sign Snoopy, down to within about 15 kilometers of the surface without landing. Command module pilot John Young flew alone in the command module, Charlie Brown, and waited. At 102 hours and 12 minutes into the flight, the 2 vehicles were on the far side of the moon, flying separately, out of radio contact with Houston for about an hour, exactly as the flight plan specified. They were preparing for a simulated ascent stage liftoff. They were also eating brownies. That detail matters more than it sounds, because of how it colors everything that follows. What the transcript actually records is this. Stafford, you want some more brownies? Cernan, no. Stafford, partly garbled, go hungry. And then Cernan, that music even sounds outer spacey, doesn't it? You hear that? That whistling sound? Stafford, yes. Cernan makes a long, low sound imitating it. Young, from the other spacecraft, did you hear that whistling sound too? Cernan, yeah. Sounds like, you know, outer space type music. Young, I wonder what it is. And then Cernan immediately changes the subject to ask whether the insulation is burned off the front of Stafford's window. "Mine's all burned off," he says. "Isn't that weird? Eerie, John." Young replies, "Yes, I got it too. I was going to see who was outside." Stafford announces that he is going to fix some grape juice. The crew carry on. They photograph craters. They check radar ranges, 269 miles, 286 miles, going right out to 310 nautical miles. They confirm the times at which each spacecraft will reacquire signal with Earth. About 6 minutes later, Cernan comes back to it. "Boy, that sure is weird music," he says. Young, "We're going to have to find out about that. Nobody will believe us." Cernan, "No. It's a whistling, you know, like an outer space type thing." And then Young, "Probably due to the VHF ranging, I'd guess." And Cernan, "Yes. I wouldn't believe there's anyone out there." That is the entirety of the incident. Read it again with attention to the sequence, because the sequence is the whole story. 3 men hear something unfamiliar. They mention it. They discuss it briefly. They go back to work. 6 minutes later, one of them raises it again, and the command module pilot proposes the correct explanation: radio interference between the 2 spacecraft's very high-frequency systems, and the lunar module pilot immediately agrees and says explicitly that he does not believe there is anyone out there. The mystery is solved inside the transcript itself by John Young, roughly 6 minutes after it started. There is something worth appreciating in the texture of that exchange, and it is not the mystery. It is the working relationship. 2 spacecraft, separated, behind the moon. 3 men who have been awake and working for hours. One of them notices something odd and says so immediately, on the shared loop, without hedging or apologizing for it. The others confirm they hear it too. Nobody dismisses it. Nobody dramatizes it. They carry it in the background for 6 minutes while attending to radar ranges and acquisition times, and then one of them, having presumably been turning it over the whole while, offers a mechanism. Probably due to the VHF ranging, I'd guess. That is not a man dismissing a colleague. That is a man who has been thinking about it. It is also worth noting what Young said just before proposing the answer: "We're going to have to find out about that. Nobody will believe us." He was wrong about the first part, in the sense that they found out about it themselves, within the minute. He was right about the second, in a way he could not have anticipated, because when the recording eventually surfaced, 47 years later, a great many people believed something considerably stranger than what he had actually said. The physical explanation held up under investigation. Apollo 8 had flown to the moon the previous Christmas, carrying only a command and service module, and its crew heard nothing like this. Apollo 10 was the first flight to carry a lunar module to the moon, and to operate 2 independent, very high-frequency radio transmitters in close proximity to each other. After the flight, the sounds were attributed to radio interference between the 2 transmitters, specifically to a beat frequency. When 2 radio signals that are close in frequency, but not identical, are mixed together, the result is a slow, warbling tone at the difference between them. It is the same phenomenon that produces the wavering sound when 2 musical instruments are slightly out of tune with each other, and any musician recognizes it instantly. That mechanism accounts for the specific character of what they described. A warbling, varied tone that is sometimes present and sometimes not is precisely the signature of beat frequencies, and interference from systems that only run part of the time explains why the sound came and went. There is a detail in the hardware that makes the timing inevitable in hindsight. The 2 spacecraft needed to know how far apart they were, and the system that measured it worked by passing signals back and forth between them on the very high-frequency band. That system had never been operated at the moon before, because no previous mission had taken 2 vehicles there to separate. Apollo 9 had flown the lunar module in Earth orbit, Apollo 8 had gone to the moon without one. Apollo 10 was the first and only combination of both conditions, which is precisely why it was the first crew to hear this, and why Apollo 8's crew had heard nothing. Michael Collins heard the same thing in lunar orbit on Apollo 11, 2 months later, and called it, memorably, a woo-woo sound. In his 1974 memoir, he wrote that NASA technicians had warned him about it in advance, and then added the sentence, that has outlived every other line written about this incident. Had I not been warned about it, it would have scared the hell out of me. That single sentence does two things at once. It confirms that the sound was real, distinctive, and unsettling. And it confirms that within 2 months of Apollo 10, the phenomenon had been identified, explained, and briefed to the next crew as a known feature of the vehicle. So where does the story go wrong? Entirely on publication timing and on a documentary trailer. NASA put the Apollo 10 transcripts online in 2008. The documents themselves indicate they would have been declassified in 1982. The audio files went online in 2012. In February 2016, a trailer for an episode of a television series presented the incident with horror movie scoring, static-filled cutaways, and unsettling narration. The story went around the world within a week. Corrections based on the actual transcript were published within days by space historians and journalists who had done nothing more complicated than read the document. Several framings from that coverage should be dismissed directly. The recordings were not classified, were not recently declassified, and were not kept under wraps for 4 decades. They had been public for 8 years and available in principle for 34. The sounds are not unexplained. And the crew were not frightened, did not panic, and did not hide anything from Houston, because the transcript shows them photographing craters, running radar checks, and dividing brownies and grape juice throughout. The far side radio blackout is heavily emphasized in the sensationalized version and is not physically relevant at all. The interference was between the 2 spacecraft, not between the spacecraft and Earth. Being out of contact with Houston had nothing to do with it. It is worth asking why this particular story traveled as far as it did, when the correction was available within days and required nothing more than reading a public document. Part of the answer is the setting. The far side of the moon is the most isolated place any human being has ever been. For about an hour per orbit, the crew of Apollo 10 were further from help and more thoroughly cut off than anyone before or since. That is a genuinely powerful piece of staging, and it costs nothing to exploit. Part of it is the audio. A warbling tone recorded on 1960s equipment sounds strange under any circumstances. Play it under the right music and it sounds like something else entirely. And part of it is that the correction is boring in exactly the way corrections usually are. Radio interference between 2 very high-frequency transmitters producing a beat frequency is not a story. It is an engineering footnote. The claim that 3 astronauts heard alien music behind the moon and never spoke of it again is a story, and it is a good one, and it survives on that basis rather than on evidence. 2 things do remain genuinely open, and they are worth stating honestly rather than glossing. The first is why the astronauts never publicly discussed it afterwards. The incident is not mentioned in John Young's memoirs and is rarely raised among space historians. One suggestion is that the men stayed quiet because any hint that they had been rattled in flight might have got them grounded. Flight status in that era depended on being seen as imperturbable, and a story about hearing strange music behind the moon was not an asset. That is a plausible hypothesis. It is not an established fact. The second is Al Worden's dissent. The Apollo 15 command module pilot said in the documentary that he does not accept the radio interference explanation. Logic tells me that if there was something recorded on there, then there was something there, he said, and argued that experienced flight crews would recognize radio interference when they heard it. The rebuttal is direct. Apollo 10 was the first crew ever to encounter this specific interference mode, produced by a hardware configuration nobody had flown before, in an environment nobody had operated in. Unfamiliarity with a genuinely novel phenomenon implies nothing whatsoever about competence, and the transcript shows that one of them worked it out anyway, in 6 minutes, without help. A small note on dating, for anyone who wants to place this precisely. The event is logged at a ground elapsed time of 102 hours and 12 minutes and computed forward from the launch time that places it around the 22nd of May 1969. Most accounts give only May 1969 because the mission clock rather than the calendar was what mattered to everyone involved. There is one more thing about that hour behind the moon that almost nobody mentions, and it puts the whole episode in proportion. About half an hour after the music conversation, Snoopy's ascent stage separated from its descent stage and immediately began spinning wildly. The horizon tumbled through the windows. Cernan's reaction went out over an open channel and became one of the more famous pieces of profanity in the history of the space program. Post-flight analysis traced the problem to a single switch left in the wrong position, which had sent the lunar module's guidance system hunting for its companion spacecraft. The crew recovered control quickly, and the mission continued. Which is to say, the genuinely dangerous thing that happened to Apollo 10 behind the moon was not the music. It was a switch, and the crew handled both of them the same way. Noticed, discussed, dealt with it, moved on. 3 men out of radio contact with every other human being alive heard something none of them could identify. They talked about it calmly for 6 minutes, worked out the answer themselves, and went back to eating brownies. Eugene Cernan would return to the moon on Apollo 17 in December 1972 and would become the last human being to walk on it. More than 50 years later, that is still true. They came home with their eyes unchanged. Not everyone does. Number 3. The eye that changed shape. John Phillips flew as NASA science officer and flight engineer on Expedition 11, launching from Baikonur aboard Soyuz TMA-6 on the 15th of April 2005, alongside Commander Sergei Krikalev. He returned in October, after roughly 6 months in orbit. Somewhere around the halfway point of that mission, he floated up to a window, looked down at the Earth, and could not bring the planet into focus. He had always had 20/20 vision. At his post-flight physical, NASA measured it at 2100. To put that in ordinary terms, he now needed to be 20 feet away from something that a normally sighted person could read at 100 feet. That is roughly the threshold at which most American states would decline to issue an unrestricted driver's license. 6 months in orbit had cost him that much, and nobody had any idea why. He was put through magnetic resonance imaging, retinal scans, neurological testing, and a spinal tap. The findings were structural, physical, and unambiguous. The backs of his eyeballs had flattened, pushing the retinas forward. His optic nerve was inflamed, and he had choroidal folds, described in coverage as something like stretch marks across the back of the eye. His eyes were a different shape than they had been when he launched. Phillips is the famous index case, but the syndrome's formal identification came later and from different people, and the sequence matters because it explains why it took so long. NASA astronaut Michael Barrett flew a 6-month station mission in 2009. Along with Canadian astronaut Robert Thirsk, he began having trouble reading his research procedures, the printed checklists and protocols that structure every working hour aboard. Stronger glasses solved the immediate problem, and for most people, that would have been the end of it. Vision changes with age. Everyone over 40 eventually needs readers. It is the least alarming symptom in medicine. But both men are physicians, and rather than accept the workaround, they investigated themselves. What they found was the classic pattern of what is now recognized as a syndrome, not the ordinary presbyopia of middle age, but a specific constellation of structural findings that should not have been there. The syndrome was first formally described in 2011, presenting clinical and imaging findings from 7 astronauts after long-duration flight. So the accurate arc runs in 3 stages. Phillips in 2005, the case nobody could explain. Barrett and Thirsk in 2009, the 2 doctor astronauts who recognized it as a pattern rather than as bad luck. And 2011, the paper that established it as a syndrome with a name. That name has changed once, and the change is informative. It was originally called visual impairment and intracranial pressure syndrome because the leading hypothesis was raised pressure inside the skull, and because the findings resemble a terrestrial condition called idiopathic intracranial hypertension. NASA later renamed it spaceflight-associated neuroocular syndrome because the pressure link turned out not to be as clean as the original name implied. Unlike patients with the terrestrial condition, astronauts do not get the severe headaches, the pulsatile tinnitus, or the double vision. Measured pressure in spaceflight is elevated only mildly. The original name had committed to a mechanism, and the mechanism did not hold up, so the name was changed to one that describes what is observed rather than what is assumed. The verified pattern is a list of physical changes to the structure of the eye. Flattening of the back of the globe, swelling of the optic nerve head, distension of the sheath around the optic nerve, folds in the choroid and the retina, cotton wool spots, which are small patches of retinal nerve fiber damage caused by restricted blood flow, and a shift toward farsightedness, which follows directly from the flattening because an eyeball that has been shortened front to back focuses light behind the retina instead of on it. The symptoms that result include decreased near vision, blind spots, headaches, and deterioration of distance vision. Blurred near vision is most common in astronauts over 40. NASA now stocks plus-powered reading glasses aboard the station in anticipation, informally called space anticipation glasses, which is a mild way of describing a supply of spectacles kept in orbit because the agency expects people's eyes to change while they are up there. The leading mechanism is called the cephalad fluid shift, and it is the most straightforward part of this entry. On Earth, gravity pulls fluid toward the feet continuously, and the body's circulatory system is built around fighting that. Remove the pull, and roughly 2 liters of blood and cerebrospinal fluid redistribute toward the head and stay there for the entire mission. 2 liters is about the volume of a large bottle of soft drink relocated into the skull and held there for 6 months. That is what produces the puffy face and thin legs that crews develop in their first days aboard, a change so visible that photographs from the first week of a mission look different from photographs taken later. The sustained headward shift is thought to raise venous and cerebrospinal pressure behind the eye, congest the ocular veins, and deform the globe from behind. Newer work implicates congestion of the ocular veins and impaired function of the brain's waste clearance system as contributing mechanisms. Contributing factors under investigation include elevated cabin carbon dioxide levels, resistance exercise regimes, and individual anatomy, because not everyone is affected equally, and nobody yet knows what makes the difference. This is an active area of research rather than settled science. There is a detail in the discovery story that deserves more attention than it usually gets, because it explains why this took 6 years to identify after Phillips came home. Vision problems are the easiest symptom in the world to explain away. Every person over 40 finds reading harder. Astronauts are, on average, well into that range. The median age on a long-duration mission is in the mid-40s. Fatigue affects vision. Poor lighting affects vision. Dehydration affects vision. A crew member who finds a checklist harder to read after 4 months in orbit has a dozen unremarkable explanations available before anyone would reach for a novel syndrome. Which means the condition was almost certainly present in crew members for years before Phillips, going unrecorded because nobody had a reason to look past the obvious answer. What broke that was 2 people who happened to have medical training and who declined to accept a workaround that worked. Barrett and Thirsk could have taken the stronger glasses and got on with the mission. Most people would have. That they instead treated their own deteriorating vision as a finding rather than a nuisance is the entire reason this is a recognized syndrome and not still an unexplained pattern. The prevalence figures require care because published numbers genuinely differ, and it is easy to make the problem sound either larger or smaller than it is. NASA has stated that over a 10-year window, approximately 1 in 3 astronauts on long-duration station missions presented with 1 or more of these ocular findings. Peer-reviewed reviews report that at least 1 feature has been documented in 81% of NASA astronauts. Other sources give around 2/3 of station crew members or 60% of astronauts after missions of 6 months or longer. Those figures are not contradicting each other. They are measuring different things, any single imaging finding versus clinically significant vision change versus the full syndrome. The honest formulation is that somewhere between 1/3 and roughly 4 in 5 long-duration crew members show at least 1 sign, depending on how strictly the condition is defined. Does it reverse? Partly, and the partly is the problem. The acute findings improve after return to gravity. The optic nerve swelling subsides. The worst of the refractive shift comes back. Most crew members can function normally within weeks, but the structural changes persist. Choroidal folds have been documented still present, though less evident, 3 years after a mission, and remained detectable on imaging up to 8 years afterward. Globe flattening and far-sighted shifts have also been documented persisting for years. And here is the single most important sentence in this entry, because it cuts directly against how this story is usually told. No crew member has yet experienced permanent vision loss from this. No irreversible blindness has occurred. Astronauts are not going blind. Headlines suggesting otherwise are wrong. What they are doing is coming home with eyes that are measurably a different shape than the ones they left with, and living with that. Why any of this matters comes down to Mars. NASA classifies the syndrome as a high risk on both likelihood of occurrence and severity of consequence, and the literature repeatedly describes it as a major barrier to planetary spaceflight. A news feature in a major journal in 2025 ran under the headline that eye problems cloud NASA's vision of Mars. The reasoning is simple and difficult to argue with. Station missions run about 6 months, and crews come home to gravity, where the acute changes reverse. A Mars mission is roughly 2 to 3 years of continuous or near-continuous weightlessness, with no early return option, no possibility of cutting the mission short because someone's vision is deteriorating. And nobody knows whether these changes plateau or keep progressing, because there is no data past about a year of continuous exposure. The longest continuous space flights in history are around 14 months. Everything beyond that is extrapolation. If a commander's near vision degrades over the course of a mission where reading a checklist correctly is the difference between landing and not landing, stronger glasses may not be enough. And there is no ophthalmologist on Mars. It is also worth noting how few people this has been observed in. The syndrome was formally described from 7 astronauts. 7. That is not a failure of the research. It is a reflection of how small the population is. Only a few hundred people have ever spent 6 continuous months in orbit, spread across 4 decades and several space agencies, and every one of them is a specialist whose time is expensive. Space medicine works with sample sizes that would be considered preliminary in any terrestrial field, and draws conclusions that have to be good enough to send people to another planet on. Countermeasures under study include lower body negative pressure devices, which mechanically draw fluid back toward the feet, and a specialized sleeping bag designed to do the same thing overnight. Head-down tilt bed rest, volunteers spending weeks lying at a slight downward angle, is the main terrestrial analog used to model the condition. This entry is the point where the list turns inward, and it is worth naming that explicitly. Everything before this, the water, the debris, the chip in the glass, the smell in the airlock, the flames, the fireflies, the volcano, the meteors, the clouds, the airglow, the shuttle's own light, the upward lightning, the mold, the aurora, the thermal blanket, the knocking, the whistling, describes something outside the observer. In every case, the impossible thing was out there, and the astronaut was the instrument recording it. Here, for the first time, the astronaut is the phenomenon. The thing that changed was not in the sky. It was the eye doing the looking, physically reshaped by the environment it was looking from. There is no shutter to close against it, no shield to interpose, and no procedure to follow. It happens gradually, over months, to a person who cannot tell it is happening except by noticing that the words on a page have got harder to read. There is one detail in this entry worth carrying forward because it connects back to something earlier on this list. The two physicians who recognized the pattern, Michael Barrett and Robert Thirsk, were aboard the station together during Expedition 20 in 2009. That is the same expedition and the same crew that photographed the Sarychev Peak eruption from orbit, 29 frames in 60 seconds, through a 400mm lens out of the window. While they were taking some of the most valuable photographs ever made from the station, they were also, quietly, noticing that they were finding it harder to read. The people we send to look at the universe on our behalf are coming home with the physical shape of their eyes altered by the act of looking. And nobody yet knows what 3 years of it would do. That is what 6 months of looking out of a window can do. The next entry is about what two men found when they opened one. Number 2. The frozen station. On the 11th of February 1985, Soviet controllers sent a routine command to the uncrewed Salyut 7 station and got nothing back. The cause was almost trivially small. A current sensor in the battery charging circuit had failed, and it was reporting the batteries as fully charged when they were not. The system did what it was designed to do with that information. It stopped charging them from the solar arrays. The batteries drained. The radios died. The heaters died. And a 20-ton space station began drifting, tumbling slowly end over end, freezing solid, entirely deaf to anything sent from the ground. There was no way to command it, no way to interrogate it, no way to establish whether anything aboard was still intact. It was simply gone, a large object in a known orbit that no longer answered. What the Soviet space program did about that is one of the most extraordinary operations ever attempted in orbit, and it is almost unknown outside specialist circles. Soyuz T-13 launched on the 6th of June 1985 with Vladimir Janibekov as commander and Viktor Savinyek as flight engineer. Janibekov was chosen because he was an exceptional manual pilot, and manual piloting was the entire point of the mission. The spacecraft had been stripped of its automatic docking system to save mass. In its place, they carried extra propellant, extra supplies, cold weather clothing, and a handheld laser rangefinder, because with the automatic system gone, there was nothing left aboard to measure the closing distance except a device held in a man's hands. On the 8th of June, Janibekov matched the rotation of a dead, tumbling, 20-ton object by eye, closed the distance by hand, and made a hard docking at the forward port. Consider what that involves. A cooperative docking target broadcasts its position and attitude, holds itself steady, and lights up a beacon. Salyut 7 did none of those things. It was rolling, at a rate nobody on the ground could measure precisely, in an orientation that had to be judged visually through a window while both vehicles moved at nearly 8 kilometers a second. To dock, he had to bring his spacecraft into a matching roll, so that from his point of view, the station appeared to hold still, and then fly straight in along an axis that was itself rotating. It is still considered one of the hardest pieces of piloting ever performed in space. They opened the hatch wearing gas masks, in case a short circuit had filled the interior with toxic products, and winter clothing including fur-lined hats. Here is what was on the other side of that hatch. There is no light. Not dim light, none, because nothing aboard has had power for 4 months, and the windows face whatever direction the station's tumble happens to be pointing them. The beams of 2 flashlights are the only illumination, and they are moving, because the men holding them are moving. The air is still. It is also freezing, cold enough that the 2 of them are working in the kind of temperature that makes hands stop functioning properly inside gloves. Janibekov reaches for a Russian word for brutal, punishing cold to describe it. And the surfaces are wrong. Everything is coated in frost. A fine white layer on the walls, on the panels, on the instrument faces, on the handrails, on equipment that was left neatly stowed by a crew that expected to come back. The water lines are frozen solid, which means there is no drinking water aboard and will not be until the ice can be melted. When they breathe, they can see it. They are floating through the inside of a space station that has become an icebox. It is not damaged. Nothing has exploded, nothing has torn, nothing has burned. It is entirely intact and completely dead, and it has been quietly turning into this for 4 months, while nobody was aboard to notice. That is the genuinely impossible thing anyone ever saw aboard Salyut 7. Not something outside a window. The inside of their own habitat, dark and silent and glittering with frost in a flashlight beam, and the knowledge that they had roughly 10 days to bring it back before their own consumables ran short. The work they had to do in that condition is worth spelling out, because the cold was not merely uncomfortable. It was the central engineering problem. Nothing aboard could be powered up carelessly. Electronics that have been cold-soaked for 4 months and are then energized can fail outright, and condensation forming on a circuit board as the interior warms will short it. So the sequence had to be gradual: establish some power, warm the station slowly, and bring systems back one at a time in an order that avoided moisture collecting where it would do damage. Meanwhile, the water was ice. Not merely cold water, the supply lines were frozen through, which meant the 2 of them had no drinking water aboard the station at all until enough heat had been restored to thaw the system. They were working out of their Soyuz for that, on a spacecraft's limited reserves, in a station the size of a small house, in the dark. They fixed it. They connected the surviving batteries directly to the solar arrays, bypassing the failed charging circuit entirely, and then used the thrusters of their own Soyuz to swing the whole combined stack around to face the sun so the arrays could take in power. Within roughly 10 days, they had restored power, heat, communications, and water. A station that had been written off was alive again, and it went on to host crews for years afterward. Janibekov returned on the 26th of September 1985, after 110 days. Savynik stayed on and came home aboard Soyuz T-14 after 168. In May 1986, Leonid Kizim and Vladimir Solovyov flew Soyuz T-15 from the brand new Mir station across to Salyut 7 and back, which remains the only crewed flight ever made between 2 space stations and which has never been repeated by anyone. Salyut 7 itself re-entered uncontrolled on the 7th of February 1991, scattering debris near Capitan Bermudez in Argentina. Nobody was hurt. There is another story attached to this station, and it has to be addressed directly, because it is far better known than everything above, and it does not survive contact with evidence. The story goes like this. On day 155 of the previous expedition, in July 1984, the station was flooded with a blinding orange light. The crew thought there had been a fire or an explosion. When their vision returned, they saw 7 enormous humanoid figures outside the windows, with faces, with bodies, with wings and halos, each one the size of an airliner, which paced the station for about 10 minutes, mirroring its movements, and then vanished. 12 days later, with a visiting crew aboard, it happened again, and all 6 cosmonauts saw the same thing. A quotation is attributed to flight engineer Vladimir Solovyov, describing 7 giant figures in the form of humans, with mist-shaped wings and halos, as in the classical representation of angels. No primary source for any of this has ever been located. That is worth stating carefully rather than dismissively, because the absence is total. No cosmonaut involved has ever given a first-person, on-the-record account. Every version of that Solovyov quotation appears only in secondary material, with no cited original publication, no date, and no named interviewer. Russian-language documentation of Salyut 7 and its expeditions contains no reference to the event. No contemporaneous news coverage from 1984 or 1985 is traceable, and the claim that the story reached international news at the time is itself unsourced. The English text also carries an internal error that gives the game away. It identifies the physician Oleg Atkov as the commander of the expedition. He was not. Leonid Kizim commanded that mission. Atkov was a cardiologist, flown specifically to run a long-duration medical program, the first physician sent to a Soviet station for that purpose. This is not an obscure detail. It is the first line of any account of the expedition. A story genuinely sourced from Soviet material would not get the commander wrong. The account also omits an entire visiting crew. Soyuz T-11 had brought India's first astronaut to the station that April, and the story presents the July visitors as though they were the only ones. And the classification claim that the incident was declared top secret and the crew ordered never to discuss it is unfalsifiable, and it does all the load-bearing work of explaining why no records exist. That is a recognizable structure. So is the fact that the story helpfully supplies its own debunking, offering oxygen levels and hallucination as possible explanations, which lends an air of balance to something that has no evidence behind it in the first place. It is worth being clear about what is and is not being claimed here, because there is a difference between saying a story is unsupported and saying the people in it were lying. Nobody is accusing Kizim, Solovyov, or Atkov of anything. There is no evidence that any of them ever told this story, which is rather the point. The account does not come from them. It comes from secondary sources that attribute words to them without saying where those words were published, when or to whom. The cosmonauts are characters in someone else's narrative, and the most likely explanation for the whole thing is that it originated as fiction or as a devotional story and lost its frame somewhere in retelling. That happens more often than people assume. A story written as a story gets summarized without attribution, the summary gets repeated, and within a few iterations it is being presented as a historical incident with a date attached. The date and the mission day count are what give this particular account its air of authority. Day 155 sounds like something read off a log. It is also the easiest part to fabricate, since anyone can count forward from a launch date. There is one further explanation sometimes offered that deserves specific rejection, because it borrows credibility from something real. Cosmic ray visual phenomena, the light flashes that astronauts genuinely do see, which are the subject of the final entry on this list, are occasionally proposed as the origin of the angel's story. They do not fit. Those flashes are brief, private, individual, and seen with the eyes closed. They are not shared 10-minute humanoid apparitions visible through a window to 6 people at once. Attaching a real phenomenon to a fabricated account does not make the account real. It only makes the real phenomenon harder to discuss. What actually happened aboard Salyut 7 in the summer of 1984 needed no embellishment at all. Kizim, Solovyov, and Atkov launched on the 8th of February 1984 and landed on the 2nd of October after 237 days, a world endurance record at the time. They performed 6 spacewalks on station repairs over the course of it. And on the 25th of July 1984, the visiting cosmonaut Svetlana Savitskaya became the first woman ever to walk in space. She spent 3 hours and 35 minutes outside, cutting and welding metal samples in vacuum. Her partner on that spacewalk was Vladimir Janibekov, the same man who 11 months later would fly a spacecraft by hand into a frozen wreck and bring it back to life. That is what was happening on that station in July 1984. A woman was welding metal in open space for the first time in human history, alongside the man who would go on to perform the most difficult docking anyone has ever attempted. The invented version of that summer involves angels. The real version involves a welding torch and, 11 months later, a flashlight in a room full of frost. There is a reason this entry sits at number 2 rather than being dismissed in a sentence, and it is not the legend. It is what the legend has cost. Salyut 7 produced 2 genuinely remarkable things: a woman welding in vacuum for the first time, and a manual docking with a dead, tumbling station followed by a 10-day resurrection in the dark. Either one would be the headline achievement of most space programs. Both are largely unknown outside the field. What most people know about Salyut 7, if they know anything, is a story about angels that nobody can source. The invented version did not merely sit alongside the real one, it replaced it. That is the general shape of the problem this list keeps running into. The fabrications are not competing with silence. They are competing with true stories that are harder to tell, and they win, because a true story requires the dates to be right. Janibekov, incidentally, has one more thing named after him. During a later flight, he noticed a wing nut spinning in weightlessness that periodically and abruptly flipped its axis of rotation, over and over, with no force acting on it. The behavior is a genuine consequence of rigid body dynamics, entirely predicted by classical mechanics, and it is now widely known as the Janibekov effect. He seems to have made a habit of noticing things. Everything on this list so far has been something seen through a window, or on a hull, or against the black outside. The last entry needs none of those things. Number 1. The light that arrives with your eyes closed. During the coast back toward Earth on Apollo 11, in late July 1969, with the cabin dark and their eyes adapted to it, Neil Armstrong and Buzz Aldrin both began seeing flashes of light. The official NASA account of it opens without any embellishment at all. Crew members of the Apollo 11 mission were the first astronauts to describe an unusual visual phenomenon associated with spaceflight, it reads, reporting faint spots or flashes of light when the cabin was dark and they had become dark adapted. There was no source. There was nothing in the cabin producing light. The flashes appeared whether their eyes were open or shut, and closing their eyes did not stop them. They were seeing light that was not there. What was happening is now understood, at least in outline, and it is the reason this entry sits at the top of this list. Cosmic rays are high-energy charged particles, many of them atomic nuclei heavier than oxygen, accelerated to enormous speeds by processes elsewhere in the galaxy, and traveling through space in all directions. Some of them were passing through the spacecraft. Some of them were passing through the crew. And some of them were passing through the men's eyes. The visual system has exactly one way of reporting that something has happened to it. When a cosmic ray nucleus crossed a retina, the retina did the only thing it knows how to do. It reported light. Every subsequent Apollo crew was asked about it, and every subsequent crew saw them. An Apollo 12 crewman described the flashes as big and bright ones all over, and noted that he had seen nothing similar during 2 earlier Earth orbital missions, which is itself a data point, since those flights stayed within the protection of Earth's magnetic field. Jim Lovell saw them on Apollo 13 and could not remember having seen them on Apollo 8. From Apollo 14 onward, NASA flew dedicated observing sessions, an hour at a time, crews wearing blindfolds, calling out each event as it happened so it could be logged. 3 shapes were catalogued. Spot or star flashes, which the crews sometimes called a supernova, accounted for 66% of events. Streak flashes accounted for about 25%. Cloud flashes made up about 8%. The descriptions the astronauts gave are precise, and they are worth hearing in their own words, because these are people trained to describe things accurately being asked to describe something with no reference point at all. David Scott, commanding Apollo 15, said the star type resembled a photographic flashbulb fired across a dark arena several hundred feet away. Edgar Mitchell, the lunar module pilot of Apollo 14, gave the only color description on record. Blue with a white cast, he said, like a blue diamond. He added that there seemed to be at least 2 flashes, a bright one followed an instant later by a more subdued one, or perhaps a halo-like effect. Stuart Rooser said the cloud type resembled a lightning discharge seen from behind distant thunderheads. And James Irwin, writing in his own book years later, described one simply as a brilliant streak across the retina. The rate is the number that makes this real, rather than anecdotal, and it is higher than almost anyone expects. After dark adaptation, Apollo crews averaged 1 flash every 2.9 minutes. That is roughly 20 per hour, 1 every 3 minutes, continuously, for as long as their eyes were closed. The average time from the start of dark adaptation to the very first flash was 19.3 minutes. A later survey of 59 astronauts who had flown to Hubble, to the International Space Station, and to Mir found a mean of 1 flash every 6.8 minutes in low Earth orbit, with rates rising with orbital altitude and inclination. So they happen on the station too, at roughly half the deep space rate, because Earth's magnetic field is deflecting a good deal of what would otherwise arrive. It is worth saying plainly that none of this was hidden. The Apollo results were published openly in 1974 under the entirely undramatic title Light Flashes Observed by Astronauts on Apollo 11 through Apollo 17. There was no concealment, no classification, and no reluctance. The agency found something strange happening to its crews, studied it for 4 missions, built dedicated hardware to investigate it, and published what it found. That matters for a list like this one, because the reflex assumption about anything unusual in spaceflight is that somebody tried to suppress it. In this case, the opposite happened. The reason we know the flash rate, the shapes, the percentages, and the individual crew descriptions is that NASA asked its astronauts to sit in the dark, wearing blindfolds, and describe what they were seeing, wrote it all down, and printed it. NASA tried to catch one in the act, and the apparatus they built for it is remarkable. The Apollo Light Flash Moving Emulsion Detector flew on Apollo 16 and 17. It was an electromechanical helmet holding glass plates coated on both sides with nuclear photographic emulsion, a medium that records the physical track of a charged particle passing through it as a line of developed grains. One set of plates was fixed around the front and sides of the head. A second set translated slowly across the first, at 10 micrometers per second, for up to an hour. That slow motion is the clever part. It converts position into time. Because the moving plate was at a known place at every moment, a track recorded in it could be dated to within about a second, which meant that when an astronaut called out a flash, the particle responsible could in principle be identified and matched to it. The Apollo 17 analysis is one of the more painstaking pieces of work in the history of the program. 2,360 particle tracks were found in the plates. 483 of those were candidates. 229 were in the front plate. 65 had passed through an eye. After the rejection criteria were applied, 15 genuine candidates remained. And of those 15, 2 coincided within 5 seconds with a flash the astronaut had actually called out. The first matched a flash reported 1,465 seconds into the session, described by the crewman simply as just a spot in the left eye. The particle had grazed the left eye, almost tangent to the retina. The second matched a flash at 2,368 seconds, a glow about 1/8 of an inch across, 3/4 of the way out, at the 10 o'clock position in the right eye. The particle's predicted position was between 8:30 and 9 o'clock, a discrepancy the authors attributed to the eye having moved. Both particles were almost certainly heavier than oxygen. That is what a match looks like. A man in a darkened spacecraft says he saw a spot in his left eye, and a piece of photographic emulsion on the side of his helmet contains the track of an atomic nucleus that went through his left eye at that second. The modeling around it puts the scale in perspective. Roughly 640 cosmic rays with an atomic charge of 6 or greater, and about 130 with a charge of 12 or greater, are predicted to pass through an astronaut's eyes during a single 60-minute session. Which is to say, in the time it takes to watch a television episode, something on the order of 600 atomic nuclei from elsewhere in the galaxy pass through a person's eyeballs. The mechanism is still genuinely debated, and popular accounts almost always get this wrong by confidently picking one answer. 2 candidates compete. The first is Cherenkov radiation, light produced when a charged particle travels through the fluid of the eye faster than light itself travels in that medium. The second is direct ionization of the retinal receptors, with the particle simply triggering the light-detecting cells mechanically as it passes through them. Accelerator experiments in 1971 pushed against Cherenkov. Researchers used mono-energetic neutron beams deliberately kept below the energy threshold at which Cherenkov light can be produced at all. 3 million electron-volt beams produced nothing. 14 million electron-volt beams produced bluish-white streaks below the Cherenkov threshold, which means Cherenkov cannot have been responsible. And beams directed through the back of the head produced flashes in only one observer, implying that the retina was being stimulated directly rather than the visual cortex. A separate team using higher energy beams recorded subjects describing luminous balls like fireworks, with fuzzy tails and heads like tiny stars, and another describing 25 to 50 bright, discrete lights, blue-white in color, coming towards him. It is worth pausing on the fact that in 1971, volunteers sat in front of particle accelerator beams aimed at their own heads in order to find out what astronauts were seeing. Later data from detectors flown aboard Mir went further. In the time windows when light flashes were being reported, the rate of heavy nuclei arriving rose 6 to 7-fold, while the proton rate only doubled. Those researchers concluded that Cherenkov radiation could be ruled out for their dataset entirely, and that heavy nuclei are the main cause. The honest summary is this. The flashes are certainly caused by cosmic rays crossing the eye. The mechanism is probably a mixture of direct ionization of retinal receptors and, in some fraction of events, Cherenkov light generated inside the eye itself. NASA's own analysis notes that the requirement to be dark adapted before the flashes appear points to the retina rather than the optic nerve, because the biochemistry of dark adaptation happens in retinal tissue. Some details have resisted explanation entirely, and they are worth knowing because they are still open. Ken Mattingly, the Apollo 16 command module pilot, was the only briefed Apollo crewman who never saw a single flash. He volunteered that he considers his own night vision poor. On Apollo 17, all 3 crewmen reported 0 events during the entire hour-long session on the way home, after 28 events during the equivalent session on the way out. NASA tested and rejected geomagnetic shielding, differences in spacecraft shielding, solar modulation, and crew fatigue as explanations for that asymmetry. It has never been resolved. And the tapes containing the detailed Apollo 15 descriptions were lost during playback to the ground. Mir cosmonaut Sergei Avdiev reported seeing fewer flashes on each of his 3 successive flights, which nobody has satisfactorily explained either. 3 long-duration missions, the same man, the same instrument in his own head, and a steadily declining count. Whether that reflects something about the solar cycle, something about his eyes, or something about how a person's attention changes once a phenomenon has stopped being novel, nobody has established. The instruments have kept improving. A silicon detector called Sili operated inside Mir from 1995 to 1998, with a 6-plane successor installed in 1997 that ran until 2000. Cosmonauts using it pressed a joystick button whenever they saw a flash, so that the detector's particle record could be matched against the moment of the report, the same principle as the Apollo helmet, with electronics instead of photographic emulsion. The shapes reported through that instrument were catalogued too, and they differ interestingly from the Apollo set. A continuous line and a line with gaps dominated, with shapeless spots, spots with a bright nucleus, and concentric circles appearing less often. A line with gaps is a peculiar thing to see. It suggests a particle crossing the retina and triggering it intermittently along the path. An 8-plane detector first operated aboard the International Space Station between the 27th of April and the 1st of May, 2002, flown with ESA astronaut Roberto Vittori. A follow-on investigation, aimed specifically at the long-term effects of these particles on the central nervous system, rather than merely on vision, was scheduled to fly after July 2006. That shift in emphasis is worth noting. The early work asked what astronauts were seeing. The later work asks what else the same particles are doing on their way through, because the eye is simply the one organ that happens to report the transit. The most affecting account comes from Jerry Lininger, who spent months aboard Mir. He wrote that during a solar storm, the flashes became directional, arriving from a particular side rather than at random. They interfered with his sleep. Closing his eyes did not help, because closing your eyes has never helped. So he tried to sleep behind the station's lead-filled batteries, positioning the densest object aboard between himself and the direction the particles were coming from. It only partly worked. One correction belongs here before the close, because it is the claim most often attached to this phenomenon. These flashes are not hallucinations, and there is no evidence that they cause measurable vision loss. They are a physical event with a physical cause, recorded by instruments, matched to individual particles, and reported consistently by nearly everyone who has been in a position to experience them. The astronauts were not imagining anything. Their eyes were working exactly as designed. That image is where this list ends, and it is why this entry is number 1. Almost every other thing on this list was outside. Water on the far side of a cloth. Debris in an orbit. A chip in a pane of glass. A smell of welding in an airlock. A flame in a chamber. Frost outside a capsule window. A column of ash. A meteor below. Clouds at 80 kilometers. A band of green at the limb. A glow on a hull. Lightning going the wrong way. Mold behind a panel. An aurora underneath. a blanket drifting away, a knock on a bulkhead, a whistle behind the moon, a station full of frost. All of it happened on the other side of something. There was always a window, a wall, a hull, a visor. The astronaut was the instrument, and the impossible thing was the subject. Only one entry before this one broke that pattern, the eye that changed shape, where the environment reached in and altered the instrument itself. This one goes further. This one is inside. There is no shutter to close against it. There is no shield thick enough, and no orientation that helps, and no procedure to follow, and nothing to photograph. It does not stop when the mission ends or when the lights go out, and it cannot be looked away from, because looking away is not something eyelids can do about this. An astronaut lying in the dark with their eyes shut, trying to sleep, is being crossed by particles that were accelerated somewhere out in the galaxy long before the solar system existed. Nuclei of iron and carbon and oxygen, flung outward by dying stars and by events far stranger than that, traveling for millions of years through nothing at all, arriving at a small pressurized volume above the Earth and passing through a human retina on their way to somewhere else. And the only reason anyone knows it is happening is that the retina keeps reporting a light that has no source. The universe does not stop at the window. It goes through the glass, and through the wall, and through the person, and the only evidence any of them ever had of it was a faint blue flash, arriving every 3 minutes, in a closed eye, in the dark. Sleep well, and good night.